There are places on Earth where nothing grows, not because of drought, not because of cold, but because the ground itself is hostile to life. From a Pennsylvania town that's been burning underground for over 60 years to a lake in Africa that turns animals to stone. From forests where radiation still glows decades after disaster, to deserts so dry they mirror the surface of Mars. These locations exist in every corner of our planet, hidden in plain sight, waiting to tell their stories of extreme geology, deadly chemistry, and the incredible limits of life on Earth. Darvaza gas crater, Turkmenistan. Long before there was fire, there was only silence in the Karakum Desert. For millions of years, natural gas had collected beneath the sands of what would become Turkmenistan, trapped in vast underground chambers by layers of rock and sediment. The nomads who crossed this wasteland knew nothing of the treasure buried beneath their feet. They saw only endless dunes stretching toward the horizon, broken by the occasional well or oasis. The Earth kept its secrets, and the gas slept undisturbed in its stone tomb. The Soviet Union changed everything. In the 1960s, Moscow's planners looked at maps of Central Asia and saw opportunity written in geological surveys. The Karakum Desert wasn't just empty space anymore. It was a resource waiting to be harvested, a way to fuel the Communist Empire's endless hunger for energy. The bureaucrats in the Ministry of Gas Industry drew lines on charts and dispatched teams of geologists to turn theory into reality. By 1970, Soviet exploration crews had established that the Karakum held some of the world's largest natural gas reserves. The desert that had seemed worthless to ancient travellers was actually sitting on top of an underground ocean of methane. All they had to do was drill down and tap into it. Simple engineering, routine work. The kind of project the Soviets had completed hundreds of times across their vast territory. The drilling team that arrived at Darvaza in early 1971 had no reason to expect anything unusual. They were veteran petroleum engineers, men who had worked the oil fields of Siberia and the gas deposits of Ukraine. Their equipment was standard Soviet industrial machinery, heavy and built to last. The plan was straightforward: drill a test well, measure the gas flow, and move on to the next site. A few weeks of work at most. But the Karakum Desert had been keeping its secrets for too long to give them up easily. On a spring morning in 1971, the drilling rig punched through the roof of an underground cavern that had been forming for geological ages. The hollow space beneath the desert floor was enormous, far larger than anyone had imagined. As soon as the drill bit broke through, the entire structure began to collapse. The drilling equipment, the workers' vehicles, everything on the surface was swallowed by the earth as tons of rock and sand cascaded into the void below. The geologists watched in horror as a crater opened before their eyes. 70 meters across and 20 meters deep, it yawned like a wound in the desert floor. But the real problem wasn't the size of the hole, it was what was coming out of it. Natural gas, the same methane that the Soviets had come to harvest, was now pouring into the atmosphere at an incredible rate. Invisible and odorless, the gas created a deadly cloud that could suffocate anyone who came too close. The men faced an impossible choice. They could try to cap the well, but that would take months of dangerous work while poisonous gas continued to leak into the air. Or they could burn it off, turning the methane into carbon dioxide and water vapour. Fire was dangerous, but gas leaks were deadly. The decision seemed obvious. Someone, somewhere in the chain of command, gave the order to light the crater. The exact identity of that person has been lost to Soviet bureaucracy and the passage of time. What matters is that in 1971, 52 years ago, a match was struck in the Karakum Desert. The methane ignited instantly, turning the crater into a bowl of flame that could be seen for miles. The geologists expected the fire to burn for a few days, maybe a week at most. The gas pocket would empty itself, the flames would die down, and they could return to seal the well properly. They packed up their remaining equipment and retreated to a safe distance to wait. They're still waiting. The fire that was supposed to last a week has been burning for more than half a century. Every day since 1971, flames have danced across the crater floor, fed by an apparently endless supply of natural gas. The methane flows up from deep underground reservoirs, ignites as it reaches the surface, and creates a permanent inferno that locals call the door to hell. The sight is both beautiful and terrifying. During the day, the crater looks almost ordinary, just a circular depression in the sand with shimmering air rising from its depths. but at night it transforms into something otherworldly. Orange and blue flames flicker across the crater walls like the campfire of giants. The light can be seen from space, a beacon of human miscalculation burning in one of Earth's most remote places. For decades, the Soviet government tried to pretend the Darvaza crater didn't exist. It wasn't marked on maps. Tourist access was forbidden. Even mentioning it could bring unwanted attention from state security. The fire burned in official secrecy, known only to the nomads who herded their animals around its edges and the occasional geologist who came to study what had gone wrong. But secrets don't stay buried forever, especially not secrets that burn bright enough to illuminate the night sky. After the Soviet Union collapsed in 1991, Turkmenistan became an independent nation desperate for tourist revenue. The crater that had once been an embarrassment became a potential gold mine. Foreign visitors began arriving to witness the door to hell, and their photographs spread across the early internet. By the 2000s, the crater had become Turkmenistan's most famous landmark. Tour companies brought busloads of adventure seekers to camp beside the flames. Social media turned the site into an Instagram sensation. The eternal fire that had started as an industrial accident was now generating millions of dollars in tourism revenue. But the novelty wore thin for Turkmenistan's leaders. President Gurbanguly Berdimuhamedov, the country's authoritarian ruler, began to see the crater as a symbol of waste rather than wonder. Every day, millions of cubic meters of natural gas worth thousands of dollars went up in smoke. Every day, the country lost revenue that could have been earned by properly harvesting and selling the methane. The door to hell was literally burning money. In January 2022, Berdimuhamedov ordered experts to find a way to extinguish the crater. He cited environmental concerns and the need to conserve natural resources, but everyone understood the real motivation. Turkmenistan needed every cubic meter of gas it could sell to international markets. The eternal flame had become an expensive luxury the country could no longer afford. Scientists and engineers from around the world have proposed various solutions. Some suggest flooding the crater with water or sand to smother the flames. Others want to drill relief wells to redirect the gas flow. A few have even proposed controlled explosions to collapse the crater walls and seal the opening. But after 50 years of burning, the underground geology has changed in unpredictable ways. No one knows exactly how much gas remains or how it's flowing through the fractured rock. Today, the door to hell continues to burn while experts debate how to close it. The flames that were supposed to last a few days have become a permanent feature of the Turkmen landscape. Tour groups still arrive to witness the spectacle, though their numbers have dwindled as the government restricts access. The crater has become a symbol of humanity's complicated relationship with the Earth's resources, a reminder that sometimes our attempts to harness nature's power create something far stranger than we intended. Lake Natron, Tanzania. When scientists first catalogued the world's most extreme water bodies, they discovered something that challenged their understanding of where life could exist. Scattered across the planet, in remote corners of every continent, they found lakes that seemed to defy the basic chemistry that sustains life on Earth. These weren't just salty like the ocean, or acidic like a lemon. These were alkaline lakes with pH levels that could strip paint and dissolve flesh, yet somehow they harboured life forms found nowhere else on the planet. The most infamous of these chemical cauldrons sits in the shadow of an active volcano in northern Tanzania. Lake Natron stretches across 60 kilometres of the East African Rift Valley, its waters burning blood red under the equatorial sun. But Natron isn't alone in its deadly beauty. From the Sierra Nevada mountains of California to the salt flats of Kenya, similar lakes dot the landscape wherever ancient volcanic activity meets the right combination of climate and geology. In California's Mono Lake, alkaline waters with a pH of 10 have carved limestone towers from the earth, creating a landscape so alien that Hollywood uses it as a stand-in for distant planets. The lake's alkalinity comes from underground springs that have been leaching sodium carbonate from volcanic rocks for thousands of years. Fish cannot survive in Mono Lake's caustic waters, but billions of brine shrimp thrive in the chemical soup, supporting massive flocks of migratory birds. Lake Magadi in Kenya presents an even more extreme version of the same phenomenon. Here, pH levels can reach 12, making the water nearly as caustic as household ammonia. The lake's surface is covered with a thick crust of trona, a mixture of sodium carbonate and sodium bicarbonate that forms crystalline islands in the middle of the acidic water. Industrial mining operations extract thousands of tons of this natural soda ash each year, but the lake continues to produce more through processes that have been ongoing for millions of years. Yet none of these extreme environments matches the deadly reputation of Lake Natron. With pH levels that can exceed 10.5 and water temperatures that regularly reach 60 degrees Celsius, Natron has earned its status as one of the most hostile bodies of water on Earth. The alkalinity comes from sodium carbonate deposits left behind by volcanic activity from nearby Old Doño Lengai, an active volcano that spews nitrocarbonatite lava, the only volcano on Earth that produces this unique type of molten rock. What makes Lake Natron particularly notorious isn't just its extreme chemistry, but what happens to animals unlucky enough to fall into its waters. The high concentration of sodium carbonate acts like a natural mummification process, calcifying organic tissue and preserving it in stone-like formations. Photographer Nick Brandt documented this phenomenon in his haunting series of images showing birds and bats that had been turned into calcified sculptures by the lake's alkaline waters. But the process isn't quite as simple as the popular media often portrays. The animals don't actually turn to stone while they're alive. Instead, creatures that die in or near the lake become coated with sodium carbonate deposits as the water evaporates. The same chemical process that ancient Egyptians used for mummification occurs naturally in Lake Natron's shallow, sun-baked edges. The high pH breaks down proteins and fats, while the sodium carbonate forms a preservative shell around the remains. This calcification process is what distinguishes alkaline lakes from their better-known cousins, the salt lakes. The Dead Sea, despite its reputation as a place where nothing can live, actually has a relatively neutral pH around 6. Its extreme salinity comes from dissolved chlorides and bromides, not the carbonate minerals that characterize true soda lakes. You can float in the Dead Sea without serious injury, though you wouldn't want to get the water in your eyes or mouth. Try the same thing in Lake Natron and the alkaline water would cause severe chemical burns within minutes. The difference lies in the underlying geology. Salt lakes like the Dead Sea form when ordinary seawater evaporates in closed basins, concentrating familiar minerals like sodium chloride. Alkaline lakes require a more specific set of conditions: volcanic activity to produce the right kinds of rocks, a closed basin to trap the water, and an arid climate to concentrate the dissolved minerals through evaporation. The volcanic connection is crucial. When lava cools and weathers, it releases sodium and potassium ions that combine with atmospheric carbon dioxide to form carbonate compounds. In most environments, these minerals wash away to the ocean, but in closed basins they accumulate over thousands of years, gradually raising the pH until the water becomes hostile to most forms of life. This process creates some of the most unique ecosystems on Earth. Lake Natron may be deadly to most animals, but it serves as the primary breeding ground for East Africa's lesser flamingos. These specialized birds have evolved to thrive in the extreme environment, feeding on blue-green algae and cyanobacteria that flourish in the alkaline water. Their legs and beaks are specially adapted to handle the caustic conditions that would kill other birds within hours. The flamingo's breeding strategy takes advantage of Lake Natron's hostile nature. Few predators can survive in the alkaline environment, making it a safe nursery for flamingo chicks. The birds build their mud nests on small islands in the middle of the lake, surrounded by water that acts as a natural moat against threats. Even humans have difficulty approaching these nesting areas without protective equipment. Similar adaptations occur in alkaline lakes around the world. Mono Lake supports a unique species of brinefly whose larvae can survive in the caustic water. Lake Magadi hosts specialized bacteria that have evolved to process the extreme concentrations of sodium carbonate. These organisms don't just survive in conditions that would be instantly lethal to most life forms, they actually require the extreme chemistry to complete their life cycles. The scientific study of these alkaline environments has revealed important insights about the limits of life on Earth and potentially beyond. NASA researchers regularly study places like Mono Lake and the Atacama Desert's alkaline pools as analogues for conditions that might exist on Mars or the moons of Jupiter and Saturn. The extremophile bacteria found in these lakes could provide clues about how life might evolve in the harsh environments of other worlds. But alkaline lakes also represent something more fundamental about our planet's chemistry. They're natural laboratories where the Earth conducts experiments in extreme biochemistry, pushing the boundaries of what's possible in terms of pH, temperature, and mineral concentration. Each lake represents a unique combination of geological history, climate, and volcanic activity that has produced its own distinct chemical signature. The comparison between these various alkaline environments reveals patterns that help scientists understand the underlying processes. Whether it's Lake Natron's deadly red waters, Mono Lake's limestone towers, or Lake Magady's crystalline crusts, they all represent variations on the same theme. What happens when volcanic geology meets arid climate in a closed basin? Valley of Death, Kamchatka, Russia. The silence is what hits you first. Not the heat, not the smell of sulfur in the air, but the absolute crushing silence that hangs over this stretch of Kamchatka wilderness, like a heavy blanket. Where you'd expect to hear birds calling or insects buzzing, there's nothing. Just the whisper of toxic gases seeping from the earth, turning this valley into one of the most dangerous places on the planet. Welcome to Russia's Valley of Death, where the ground itself exhales poison. Every year, researchers find fresh corpses scattered across this 2-kilometer stretch of land at the foot of Kikpinich volcano. Bears that wandered too close and never wandered away. Birds that dropped from the sky mid-flight. Even wolverines, some of nature's toughest survivors, lie frozen in time where they took their last breath. The bodies don't decay here. The same gases that killed these animals also kill the bacteria that would normally break them down. Scientists have measured the cocktail of death that seeps from the volcanic vents: hydrogen sulfide, carbon dioxide, carbon monoxide, and sulfur dioxide. These invisible killers pool in the low-lying areas, creating death traps that claim lives year after year. The concentrations are so high that a brown bear can die within minutes of entering certain spots in the valley. But Kamchatka's Valley of Death isn't alone in its lethal embrace. Around the world, the Earth breathes poison through similar volcanic gas seeps, each one a reminder that our planet can be as hostile as it is beautiful. 8,000 miles away in California, Mammoth Mountain tells a nearly identical story. In the 1990s, visitors to Horseshoe Lake began noticing something disturbing. Acres of healthy pine and fir trees were dying, their needles turning brown before the trees collapsed entirely. The cause wasn't disease or drought, it was carbon dioxide seeping up through the soil from the volcano below. The gas concentrations at Horseshoe Lake reached deadly levels. Park rangers found dead birds in the same low-lying areas where the trees had died. In one documented case, a cross-country skier nearly lost his life when he stopped to rest in a depression where CO2 had pooled. The invisible gas displaced the oxygen around him, and he barely escaped with his life. The death zone at Mammoth covers over 100 acres. Soil measurements show carbon dioxide levels 40 times higher than normal atmospheric concentrations. Just like in Kamchatka's Valley of Death, the gas kills everything it touches, creating an eerie landscape of dead trees standing like monuments to the volcano's hidden power. Halfway around the world, Italy's Grotta del Cane, the dog cave, has been demonstrating the lethal power of volcanic gases for over 2,000 years. Ancient Romans knew about this cave near Naples, where carbon dioxide pools at ground level like an invisible lake. They discovered that dogs brought into the cave would collapse and die within minutes, while humans standing upright could survive because the deadly gas hugged the floor. The cave became a gruesome tourist attraction. Visitors would pay to watch as local guides lowered dogs into the CO2 layer, then quickly pulled them out to demonstrate the gas's effects. The dogs would appear to die, then miraculously revive when lifted above the gas layer where oxygen was available. This wasn't magic, it was a deadly demonstration of how carbon dioxide displaces oxygen, creating invisible death zones. Modern measurements at Grotta del Cane show CO2 concentrations reaching 70% at floor level, enough to kill within minutes. The gas seeps continuously from underground volcanic sources, maintaining its lethal presence century after century. Indonesia's Dieng Plateau shows how quickly these invisible killers can strike populated areas. In 1979, residents in several villages on the plateau woke to find their neighbours dead in their homes, their livestock collapsed in the fields. Carbon dioxide had seeped up through cracks in the volcanic soil during the night, flowing like a river of death through the low-lying areas where people lived. The gas killed 149 people in that single night. Survivors described how the deadly cloud moved visibly across the landscape in the early morning hours. a white mist that brought death to everything in its path. Children sleeping on floor mats died while their parents, sleeping in elevated beds, survived. The gas's tendency to hug the ground created a cruel lottery of survival based on elevation. Emergency responders found entire families dead in their homes with no signs of struggle or violence. The victims had simply stopped breathing as the carbon dioxide displaced the oxygen in their lungs. Animals throughout the affected area lay dead in the fields, chickens, goats, cattle, all killed by the same invisible enemy. These death valleys share common characteristics that make them particularly dangerous. Volcanic gases are heavier than air, so they flow downhill and collect in depressions like water. They're often odorless or masked by other volcanic smells, giving no warning of their presence. Most deadly of all, they kill by displacement, not by poisoning the blood, but by simply pushing oxygen out of the lungs. Carbon dioxide becomes dangerous at concentrations above 3%. At 7%, it causes immediate unconsciousness. At 10%, it brings rapid death. Hydrogen sulfide paralyzes the nervous system in high concentrations, preventing victims from recognizing danger or escaping. These gases work together, creating death traps that can kill the strongest animals within minutes. The volcanic sources of these gases tell the story of our planet's restless interior. Deep beneath the surface, magma releases dissolved gases as it rises toward the crust. These gases find pathways through cracks and fissures, emerging at the surface in concentrated streams that can persist for decades or centuries. At Kamchatka's Valley of Death, the Kikpinich volcano acts like a giant chimney, venting gases from deep magma chambers. The valley's topography creates a natural trap, preventing the gases from dispersing into the atmosphere. Instead, they accumulate in deadly concentrations that turn this wilderness into a no-man's land. Mammoth Mountain's gas emissions come from a different source magma intrusion beneath the volcano that began in 1989. Earthquake swarms indicated magma movement, and soon after, the tree killing began. The volcano hasn't erupted, but it continues to exhale deadly gases through soil and springs, creating permanent dead zones that expand and contract based on underground pressure changes. Research at these sites reveals the complex relationship between volcanic activity and gas emissions. At some locations, gas output increases before eruptions, making them valuable early warning systems. At others, like Mammoth Mountain, high gas emissions can persist for decades without any explosive activity. The Dieng Plateau's 1979 disaster shows how quickly conditions can change. The carbon dioxide release wasn't preceded by obvious volcanic activity. Instead, underground pressure changes caused by tectonic movement open new pathways for gas escape. Within hours, lethal concentrations had built up across several square kilometers. Scientists monitoring these death valleys use specialized equipment to map gas concentrations and track changes over time. Infrared cameras can sometimes detect CO2 plumes, while chemical sensors measure gas levels continuously. This monitoring is crucial because wind patterns, temperature changes, and atmospheric pressure can all affect how these gases behave at the surface. The physics of gas behavior in these valleys follows predictable patterns. Cold air increases gas density, making concentrations more dangerous. Calm weather allows gases to accumulate, while wind disperses them. Temperature inversions can trap gases close to the ground for extended periods, creating conditions where death zones persist for days or weeks. Understanding these patterns helps scientists predict when conditions might become particularly dangerous. At Mammoth Mountain, researchers have identified weather conditions that increase risk to visitors. Similar monitoring at volcanic sites worldwide helps protect both researchers and local populations from these invisible threats. The death valleys represent more than just curiosities or natural hazards. They're windows into the Earth's interior processes, showing us how our planet's internal energy reaches the surface in ways that can be both creative and destructive. The same volcanic processes that build mountains and create new land also produce these zones where life cannot survive. These sites challenge our understanding of habitability on Earth and other planets. If such small concentrations of volcanic gases can create death zones on our life-rich planet, what might similar processes mean for the possibility of life on volcanic worlds elsewhere in the solar system? The persistence of these death valleys also demonstrates the long-term effects of volcanic activity. Some have been claiming lives for centuries. their deadly embrace unchanged by human activity or climate variations. Chernobyl Exclusion Zone, Ukraine. It was May 8, 1986, 12 days after the explosion. Senior Lieutenant Valerius Starodumov stood at the edge of what had once been a lush pine forest, watching his men prepare their equipment. The trees stretched before them like a nightmare painted in rust and copper. Where green needles should have swayed in the spring breeze, thousands of pines stood frozen in death. Their branches turned a sickening reddish-brown that gave the area its haunting name, the Red Forest. Starodumov had been a liquidator for less than 2 weeks, but he already understood the weight of invisible death. The Geiger counter in his hand clicked frantically as he approached the tree line. 8,000 Roentgens per hour, 10,000 in some spots. Numbers that meant nothing to most people, but to him represented a death sentence measured in minutes. The trees had absorbed more radiation in a single night than a human could survive in a lifetime. The men called it the Devil's Garden. Nothing would grow here again, they whispered. The earth itself had been poisoned. But Starodumov had his orders. The contaminated forest had to be cleared, the radioactive trees buried. Someone had to walk into that crimson hell and tear it down piece by piece. His hands shook as he adjusted his respirator. Not from fear, he told himself, but from the radiation sickness that was already beginning to course through his body. His throat burned. His voice had begun to fade 3 days earlier, like so many of the other liquidators. The radiation always took the throat first, they learned, then the stomach, then everything else. The Red Forest wasn't just a forest anymore. It was a monument to humanity's greatest mistake. A 10-square-kilometre graveyard where every tree had died in a single night. When Reactor 4 exploded on April 26, 1986, it had hurled more radioactive material into the atmosphere than all the atomic bombs ever tested combined. The invisible cloud of death had swept west from the Chernobyl nuclear power plant, and the first thing it touched was this stand of Scots pines. The trees never stood a chance. Within hours of the explosion, radiation levels in the forest reached 8,000 to 10,000 Roentgens per hour. For comparison, exposure to just 400 Roentgens would kill half of all humans within a month. The pines absorbed the radioactive particles through their needles, their bark, their very roots. The chlorophyll that gave them life began to break down at the molecular level. Green turned to yellow, yellow to brown, brown to that terrible rusty red that would haunt the memories of every liquidator who saw it. By dawn on April 27th, the forest was dying. By the end of the week it was dead, completely, utterly dead. No bird sang in those branches, no insect crawled through the radioactive soil. Even the bacteria that normally decomposed fallen leaves couldn't survive. The Red Forest had become something unprecedented in Earth's history, a place where life itself simply ceased to exist. The Soviet authorities knew they had a problem that extended far beyond the reactor itself. The Red Forest sat directly in the path of the prevailing winds, a massive reservoir of radioactive contamination that could spread poison across Europe for decades. Every rainstorm would wash radioactive particles into the groundwater. Every strong wind would lift contaminated dust into the air. The trees had become weapons of mass destruction simply by dying. That's when they called in the liquidators. Young men, most of them, drafted from across the Soviet Union to clean up the mess that science had made. They came from collective farms and factory towns, carrying shovels and saws instead of rifles. Their enemy wasn't human, but atomic, invisible and patient and absolutely lethal. Starodumov watched his squad spread out among the dead trees. Each man wore a lead-lined apron that weighed 30 pounds and offered little protection against the gamma radiation streaming from every surface. Their dosimeters clicked like metallic rain. 20 Roentgens per hour. 50. In some spots near the reactor, the needles buried themselves against the maximum reading. The work was methodical and horrifying. Cut down the tree, saw it into sections, load the sections onto trucks lined with lead sheeting, drive the trucks to massive burial pits dug by remote-controlled bulldozers, dump the radioactive wood into the earth and cover it with concrete and clay, then do it again and again, tree by tree by tree. The men worked in 15-minute shifts. Any longer and they would exceed their daily radiation allowance. Any longer and they would start dying faster than they already were. Because they were all dying, slowly but certainly. The radiation was rewriting the code of their cells, turning their own bodies against them. Some would last months, some years. A few might even see old age. But the red forest had marked every one of them. As the weeks passed, the forest gradually disappeared. 10 square kilometres of radioactive trees vanished into burial trenches that stretched across the exclusion zone like open wounds in the earth. The liquidators worked through spring and into summer, their faces growing pale, their hair falling out in clumps, their voices fading to whispers. But even as they cleared the forest, new horrors emerged. The saplings that tried to grow back came up twisted and wrong. Mutations that had no names. Pine needles that grew in spirals. Branches that forked and forked again until they looked like reaching fingers. The radiation had changed the very DNA of the surviving seeds, creating monsters in miniature. Today, nearly 4 decades later, the red forest remains one of the most radioactive places on Earth. New trees have grown, but they grow differently. Slower, stranger. Scientists who study the area still find radiation levels that would be instantly fatal to humans. The soil itself glows on infrared cameras, heated by the decay of radioactive isotopes that will remain dangerous for thousands of years. Starodumov survived longer than most of his squad. He lived to see the Soviet Union collapse, to watch Ukraine become independent, to witness the rise of nuclear power around the world. But he never forgot those 15-minute shifts in the red forest. The weight of the lead apron, the taste of copper in his mouth, the way the dead trees seemed to whisper in the wind. He died in 2003, his body finally surrendering to the radiation he'd absorbed 17 years earlier. His death certificate listed cancer, but everyone who knew him understood the truth. The red forest had claimed him, just as it had claimed thousands of other liquidators. The invisible enemy had simply taken longer to finish its work. In his final interview, Starodumov was asked if he regretted volunteering for the cleanup. He thought for a long moment, his voice barely audible after decades of radiation damage. "We saved the world," he whispered. "We walked into hell and saved the world. Someone had to do it. Someone had to make the forest safe again, even if it killed us, even if it killed all of us." Centralia, Pennsylvania. Todd Domboski was just doing what 12-year-old boys do on a Saturday afternoon in February. He was cutting through his grandmother's backyard in Centralia, Pennsylvania, taking a shortcut to visit a friend. The ground looked normal enough, a thin layer of snow covering the familiar yard where he'd played countless times before. Then, without warning, the earth opened beneath his feet. The hole was 4 feet wide and 150 feet deep, and it exhaled a deadly mixture of carbon monoxide and scorching heat from the fires burning far below. Todd dropped through the snow-covered surface and found himself dangling by his arms, his cousin Eric frantically grabbing him from above as toxic gases swirled around his legs. The temperature down there was over 200 degrees Fahrenheit. If his cousin hadn't been quick, if Todd had fallen just a few feet deeper, the boy would have been cooked alive by the underground inferno that had been consuming his hometown for 19 years. That Valentine's Day in 1981 changed everything for Centralia. Todd's near-death experience became the moment when America woke up to the reality that an entire town was slowly being devoured by fire, a fire that still burns today more than 60 years after it first sparked to life. Centralia wasn't always a place where children fell through the earth into fiery pits. For over a century, it was a thriving coal mining town nestled in the mountains of Columbia County, Pennsylvania. The town reached its peak in the 1890s, when over 2,700 people called it home. 5 hotels served travelers, and the mines employed hundreds of men who descended into the earth each day to extract the anthracite coal that heated homes across the northeast. The coal seams beneath Centralia were part of the massive St. Clair vein, some of the richest anthracite deposits in Pennsylvania. These weren't ordinary coal seams. Anthracite burns hotter and cleaner than regular coal, making it incredibly valuable. But that same quality that made it valuable also made it dangerous. Once anthracite catches fire underground, it can burn for decades or even centuries, consuming everything in its path. By 1962, most of the profitable mining had ended, leaving behind a honeycomb of abandoned tunnels and shafts beneath the town. The borough decided to clean up an old strip mine pit that had become an unofficial garbage dump. On May 27, 1962, they set fire to the trash, just like they'd done many times before. But this time was different. The fire found its way into an exposed coal seam at the bottom of the pit. What happened next followed the predictable laws of combustion chemistry, but on a scale that would consume an entire community. Coal fires need three things to survive: fuel, oxygen, and heat. Underground, Centralia had all three in abundance. The abandoned mine tunnels acted like a giant bellows system, drawing in fresh air through one opening and exhausting hot gases through another. The coal seams provided virtually unlimited fuel, and once the fire established itself in the rich anthracite deposits, it generated enough heat to sustain itself indefinitely. The underground fire spread through the maze of old mine tunnels like blood through arteries. Anthracite burns at temperatures exceeding 1,000 degrees Fahrenheit, hot enough to crack rock and create new pathways for the fire to spread. As the fire consumed coal pillars that had been left to support tunnel roofs, the overlying rock began to collapse, creating new ventilation shafts that fed the fire with fresh oxygen. The chemistry of coal combustion creates a deadly cocktail of byproducts. When coal burns with insufficient oxygen, common in underground fires, it produces carbon monoxide, a colourless, odourless gas that binds to hemoglobin 200 times more readily than oxygen. The fire also generates carbon dioxide, hydrogen sulfide, sulfur dioxide, and dozens of other toxic compounds. These gases follow the path of least resistance, seeping up through cracks in the ground and into basements throughout Centralia. For nearly 2 decades, the fire spread beneath the town while life above ground continued with an increasingly dangerous normalcy. Residents noticed their basements getting warmer. Snow melted in strange patterns on some lawns. Trees and gardens died for no apparent reason. Gas station owner John Coddington watched his underground fuel tanks heat up so much that gasoline began vaporizing. A single spark could have leveled half the town. But it was the human stories that revealed the true horror of living above an underground inferno. Helen Woomer, a lifelong Centralia resident, watched her garden die as toxic gases seeped through the soil. Her basement became so hot she couldn't store food there anymore. When she tested the air in her home, she found carbon monoxide levels that should have killed her. Joan Girolami lived on the opposite end of town from Helen Woomer, but her experience was eerily similar. The ground around her house became too hot to walk on barefoot. Steam rose from her yard on cold mornings. When she put a thermometer in her garden soil, it registered over 180 degrees Fahrenheit. The gas company came to check for leaks, but the problem wasn't with their pipes. It was coming from much deeper underground. The fire created its own weather system beneath the town. Hot gases rose through cracks and fissures, creating updrafts that drew in fresh air from other openings. This circulation pattern meant the fire could spread for miles underground, while only occasionally revealing itself at the surface. Residents never knew where the next gas vent would appear, or how hot the ground beneath their feet might become. Temperature measurements taken throughout the 1970s showed the scope of the disaster. Surface temperatures reached 200 degrees Fahrenheit in some areas. Subsurface temperatures exceeded 1,000 degrees. The fire had spread through an estimated 350 acres of underground coal seams, with tendrils reaching toward neighbouring communities. The heat was so intense, it began affecting the structural integrity of buildings throughout the borough. After Todd Domboski's close call, government investigators finally grasped the true extent of the danger. They found carbon monoxide levels in some homes that were immediately life-threatening. In one basement, Colorado levels reached 500 parts per million, enough to cause unconsciousness within minutes and death within an hour. The fire wasn't just burning coal, it was slowly poisoning an entire community. The evacuation of Centralia began in earnest in 1984, when the federal government offered to relocate residents whose homes were directly threatened by the fire. But the human cost couldn't be measured in dollars alone. These were families who had lived in Centralia for generations, whose ancestors had worked the mines and built the community. Helen Woomer fought the relocation efforts, determined to stay in the house where she'd raised her children. Joan Girolami, despite living directly above some of the hottest areas of the fire, refused to believe her home was truly in danger. The conflict between residents created bitter divisions that persist today. Some blamed the government for not acting sooner. Others blamed neighbours for accepting buyout money and abandoning the community. Helen Woomer and Joan Girolami, once friends, became bitter enemies as they took opposite sides in the relocation debate. When they appeared on television shows together, they refused to ride in the same car to the studio. By 1992, the federal government had had enough. Congress passed legislation using eminent domain to claim all the property in Centralia, giving remaining residents the right to stay but making it clear their homes would never again be safe for habitation. The post office closed, the zip code was revoked, street signs came down, Centralia officially ceased to exist as a municipality. Today only a handful of residents remain in what was once a town of over 1,000 people. The fire continues to burn beneath their feet, now covering an estimated 3,700 acres underground. Government estimates suggest it has enough fuel to burn for another 250 years. The cost of extinguishing it would exceed $600 million, far more than the federal government spent relocating the entire population. Todd Domboski, now in his 50s, still lives in the area and occasionally visits the site where he nearly died. The hole that opened beneath him has long since been filled, but similar sinkholes continue to appear throughout the former town. The graffiti-covered section of Route 61 that was closed due to fire damage has become a tourist attraction, drawing thousands of visitors each year to see the town that burns beneath. The few remaining residents have learned to live with their underground neighbour. They test their air regularly for carbon monoxide. They check ground temperatures before walking in their yards. They've developed an intimate knowledge of how wind patterns affect gas emissions and which weather conditions make their homes more dangerous. In winter, they can track the fire's movement by watching where snow melts first on the mountainside. Atacama Desert, Chile. Picture standing on the surface of Mars endless stretches of rust-coloured rock, ancient riverbeds carved in stone, and a silence so complete it seems to press against your eardrums. Now open your eyes. You're not on Mars at all. You're in Chile's Atacama Desert, where the landscape is so alien that NASA uses this place to test equipment bound for the Red Planet. Here, in valleys that haven't seen rain for over 400 years, we find conditions more similar to Mars than anywhere else on Earth. The Atacama holds the title as the driest non-polar desert on our planet, but it's not alone in its battle against water. Across the globe, other deserts wage their own wars against moisture, each developing unique strategies for survival in a world where a single raindrop becomes a precious commodity. Yet none have achieved the Atacama's perfect recipe for absolute aridity. When scientists measure rainfall in most places, they use inches or centimetres. In the Atacama, they measure in millimetres, and even then, many weather stations record zero precipitation year after year. Some monitoring stations in the desert's core haven't recorded measurable rainfall in over 2 decades. The average annual precipitation across the entire desert is less than 1 millimetre. That's about the thickness of a dime. Compare this to other famous dry places. The Sahara Desert, despite its reputation for brutal aridity, receives an average of 25 millimetres of rain per year, 25 times more than the Atacama. Death Valley in California, known for its scorching temperatures and death-dealing conditions, gets about 60 millimetres annually. Even the Gobi Desert in Mongolia, one of the harshest cold deserts on Earth, receives around 150 millimetres of precipitation each year. The contest becomes even more dramatic when we look at specific locations. Aswan, Egypt sits at the edge of the Sahara and receives about 0.8 millimetres of rain per year. The Libyan Desert, one of the driest sections of the Sahara, might go several years without any measurable precipitation. But in the Atacama's hyper-arid core, weather stations have operated for decades without recording a single drop of rain. What makes the Atacama so uniquely dry isn't just one factor. It's a perfect storm of geographical and meteorological conditions that work together to create the most water-starved place on Earth. The desert sits trapped between 2 massive mountain ranges that act like walls against moisture. To the east, the towering Andes Mountains block humid air masses from the Amazon basin. To the west, the Chilean coastal range prevents moist air from the Pacific Ocean from reaching the interior. This double rain shadow effect creates what meteorologists call a precipitation desert. Humid air masses approaching from either direction are forced upward by the mountains, cooling as they rise. As the air cools, its moisture condenses and falls as rain or snow on the mountain slopes, leaving the air masses dry and depleted by the time they descend into the Atacama. But the mountains are just the beginning of the Atacama's drought-making machinery. The desert sits directly under the South Pacific High, a massive high-pressure system that acts like an atmospheric lid, preventing clouds from forming. High-pressure systems are characterized by descending air, and as air descends it warms and becomes less likely to produce precipitation. This high-pressure dome sits over the Atacama with remarkable persistence, creating clear skies month after month, year after year. The ocean adds another layer to this moisture-blocking system. The cold Humboldt Current flows northward along Chile's coast, carrying frigid water from Antarctica. When warm, moist air from the Pacific passes over this cold current, it cools rapidly, causing its moisture to condense before it can reach land. The result is a thick marine layer of fog and clouds that hugs the coast, but rarely penetrates inland to where rain might actually fall. This coastal fog represents one of the great ironies of the Atacama, a desert dying of thirst that sits next to an ocean, with moisture hanging tantalizingly close, in the form of fog banks that roll in from the sea but evaporate before reaching the interior valleys. The fog provides just enough moisture to support some specialized plant life along the coast, but the interior remains bone dry. The Atacama's geology tells the story of this extreme aridity, written in stone and salt. In most deserts, flash floods occasionally carve new channels and reshape the landscape. Not here. Some valleys in the Atacama have remained unchanged for millions of years. Ancient riverbeds, carved when the climate was different, still show the exact patterns they had when water last flowed through them over 15 million years ago. The lack of water has preserved landscapes with stunning precision. Meteorite impacts that would be erased by erosion in wetter climates remain pristine for thousands of years. Animal tracks pressed into ancient mudflats are still visible after millennia. Even human artifacts left by pre-Columbian civilizations remain exactly where they were abandoned, mummified by the absolute dryness. This preservation extends to microscopic life. In most deserts, soil contains diverse communities of bacteria and other microorganisms that can survive on minimal moisture. In the Atacama's core, scientists have found soils that are essentially sterile, completely devoid of detectable life. These soils are so dry that they preserve organic molecules that would decompose quickly in more humid environments, creating a natural laboratory for studying the limits of life on Earth. The extreme dryness creates chemical conditions found nowhere else on our planet. Salts that would normally dissolve in groundwater accumulate in massive deposits. Perchlorate compounds, highly toxic chemicals that destroy organic molecules, concentrate in the soil at levels that would be immediately lethal to most life forms. These same chemicals have been detected on Mars, making the Atacama an ideal testing ground for life detection instruments bound for the Red Planet. Temperature patterns in the Atacama reveal another dimension of its extremeness. While other deserts experience dramatic temperature swings between day and night, the Atacama's dryness creates its own thermal regime. Without moisture in the air to trap heat, surface temperatures can swing from 60 degrees Fahrenheit during the day to well below freezing at night. This thermal cycling, combined with the complete absence of water, creates conditions that even desert-adapted life forms cannot survive. The atmospheric conditions above the Atacama have made it a mecca for astronomical observations. The combination of high altitude, clear skies, and extremely low humidity creates some of the best stargazing conditions on Earth. Major observatories dot the desert's peaks, taking advantage of air so dry and clear that it barely interferes with incoming light from distant stars and galaxies. When rain does occasionally fall in the Atacama, perhaps once every few years in the most arid areas, the results are often catastrophic for the specialized life forms that have adapted to complete dryness. Desert blooms, which bring spectacular displays of color to other arid regions, can actually destroy established ecosystems in the Atacama. Plants and microorganisms that have evolved to survive on fog and dew can be killed by the shock of actual liquid water. These rare precipitation events also reveal the desert's complete lack of drainage infrastructure. Valleys that haven't seen water for decades can be transformed instantly into raging torrents during the brief rainy periods. The bone-dry soil, compressed and sealed by years of drought, can't absorb the sudden influx of water, leading to flash floods in places where no water has flowed in living memory. The Atacama's hyper-aridity extends deep underground. In most deserts, groundwater tables exist at some depth, even if they're too deep for surface life to access. In the Atacama's core, researchers have drilled hundreds of feet down without finding any trace of liquid water. The rock itself is desiccated, creating conditions similar to what we might find in the subsurface of Mars. This underground dryness has created unique mineral formations. Deposits of pure salt extend for miles beneath the surface, formed not by evaporation of ancient seas, but by the concentration of atmospheric salts over millions of years. These salt layers preserve chemical signatures of ancient atmospheric conditions, creating a geological record of the desert's battle against moisture stretching back millions of years. Research in the Atacama has revolutionized our understanding of life's limits. The discovery of soils more sterile than spacecraft clean rooms has forced scientists to reconsider what conditions might support life on other planets. If life can't survive in the Atacama's hyper-arid core, what does that mean for the possibility of life in similar environments on Mars or other worlds? McMurdo Dry Valleys, Antarctica. In the most ice-covered continent on Earth, there exists a place where snow never falls and ice cannot form. Here, in Antarctica's McMurdo Dry Valleys, the ground is bare and rocky, the air is bone dry, and the silence is so complete that your own heartbeat becomes the loudest sound for miles. This is one of the most alien landscapes on our planet, a desert more hostile than the Sahara, sitting in the middle of the world's largest ice sheet. When British explorer Robert Falcon Scott first stumbled upon these valleys in 1903, he couldn't believe what he was seeing. His expedition had been struggling across the Ross Ice Shelf, pulling sledges through deep snow and battling brutal Antarctic conditions, when they encountered something that defied everything they knew about Antarctica. Ahead of them stretched a valley completely free of snow and ice, a brown, rocky landscape that looked more like Mars than the frozen continent they were exploring. Scott's diary entry from December 30th, 1903 captures his bewilderment. "We have seen no living thing, not even a moss or lichen. All we found was one solitary skua gull flying up the valley. It is certainly a valley of the dead." He named it simply Dry Valley, unable to comprehend how such a place could exist in Antarctica. What Scott had discovered would later be recognised as the largest ice-free area in Antarctica, over 1,500 square miles of desert in the world's most frozen continent. For decades after Scott's discovery, these valleys remained one of Antarctica's greatest mysteries. Early explorers reported temperatures that could drop to minus 50 degrees Fahrenheit, yet no ice formed on the ground. They found rocks that had sat undisturbed for millions of years, their surfaces worn smooth not by ice or water, but by wind-blown sand. Most puzzling of all, they discovered lakes that never froze, despite being surrounded by one of the harshest environments on Earth. The first scientific expeditions to the valleys in the 1950s began to unravel the mystery, but what they found only deepened the puzzle. The valleys weren't just ice-free, they were actively hostile to ice formation. Any snow that dared to fall here disappeared within hours, not by melting but by sublimating directly from solid to vapour. The valleys seemed to possess an invisible force that repelled moisture, creating a pocket of desert in the heart of the frozen continent. The secret to the valley's impossible dryness lies in one of nature's most powerful weather phenomena, katabatic winds. These aren't ordinary winds, they're gravity-driven rivers of air that flow downhill from Antarctica's massive ice plateau like invisible waterfalls. As the dense, cold air masses from the interior ice sheets encounter the valleys, they accelerate through the narrow passages, reaching speeds that can exceed 200 miles per hour. But speed alone doesn't explain the valley's unique characteristics. These katabatic winds carry almost no moisture because they originate from the ultra-dry interior of Antarctica, where the air has been wrung completely dry by the extreme cold. As the winds descend into the valleys, they warm slightly through compression, increasing their capacity to hold moisture. This creates a powerful drying effect that sucks every trace of water from the environment. The wind system works like a giant dehumidifier that never stops running. Any snow that falls is immediately caught up in the fierce air currents and either blown away or sublimated by the constant movement of dry air. Ice that tries to form is sandblasted away by particles carried in the wind. Even the rocks themselves are gradually being carved and polished by this relentless aeolian erosion. Temperature measurements throughout the valleys reveal the complex thermal dynamics at work. While Antarctic standards might suggest these are relatively warm areas, the reality is more nuanced. Surface temperatures can swing from minus 40 degrees Fahrenheit in winter to above freezing in summer, but the constant wind chill keeps conditions brutally hostile. The winds create their own microclimate, preventing the stable cold conditions that would allow ice to accumulate. Scientific instruments placed throughout the valleys have recorded wind events that transform the entire landscape within hours. During major katabatic windstorms, researchers have measured temperature increases of 40 degrees Fahrenheit as the winds descend and warm. These dramatic warming events can turn the valleys from frozen wastelands into relatively temperate deserts in a matter of hours, only to plunge back into deep cold when the winds subside. The valley's unique hydrology adds another layer to their mystery. Despite receiving virtually no precipitation, they contain some of the most unusual bodies of water on Earth. Lake Vanda in Wright Valley maintains liquid water year-round despite being surrounded by permafrost and subjected to temperatures that regularly drop far below freezing. The lake's secret lies in its extreme salinity. It's nearly 10 times saltier than seawater, lowering its freezing point to well below zero. Even more extreme is Don Juan Pond, which holds the distinction of being the saltiest body of water on Earth. With a salinity level 18 times greater than the ocean, this shallow pond never freezes even when temperatures drop to minus 50 degrees Fahrenheit. The pond's water is so dense with dissolved salts, primarily calcium chloride, that it has the consistency of light syrup and can preserve organic materials indefinitely. The chemistry of these hypersaline lakes reveals the valley's ancient history. The salts aren't from evaporated seawater, they're the concentrated remains of millions of years of chemical weathering. As the katabatic winds break down the valley rocks grain by grain, they release minerals that gradually accumulate in the few spots where liquid water can exist. The result is a collection of the most chemically extreme lakes on Earth. Biological surveys of the valleys have uncovered life forms that challenge our understanding of survival limits. In the perpetually frozen soils, scientists have found bacteria that remain dormant for thousands of years, waiting for the brief moments when conditions allow them to metabolize. These organisms have evolved to survive not just the extreme cold and dryness, but also the constant bombardment of ultraviolet radiation that penetrates the thin, clear Antarctic atmosphere. The discovery of life in the valleys has made them a crucial analogue for astrobiology research. The conditions here, extreme cold, high radiation, virtually no liquid water, and toxic soil chemistry, closely match what we expect to find on Mars. NASA regularly tests equipment destined for Mars missions in the McMurdo Dry Valleys, using them as the closest thing to an alien world we can find on Earth. Recent research has revealed that the valley's extreme conditions are actually getting more extreme. Climate monitoring stations show that the katabatic winds have been intensifying over the past several decades, making the valleys even drier and more hostile to ice formation. This trend runs counter to the global warming patterns affecting most of Antarctica, suggesting that the valleys operate under their own unique climate rules. The valley's geology tells a story of long-term stability that's almost unprecedented on Earth. Some of the rock formations here have remained unchanged for over 8 million years, longer than the existence of the Mediterranean Sea or the Colorado River. The lack of liquid water means there's virtually no chemical weathering, and the constant winds prevent the accumulation of sediments. The result is a landscape frozen in time on a scale that's difficult to comprehend. Modern satellite imagery has revealed the full extent of the valley system and identified previously unknown ice-free areas throughout Antarctica. The McMurdo Dry Valleys are just the largest and most accessible of these desert oases. Similar but smaller ice-free zones exist throughout the continent, each one a testament to the power of katabatic winds to create impossible landscapes in the world's most frozen places. The ongoing research in the valleys continues to produce surprises that challenge our understanding of how extreme environments work. Recent discoveries include underground rivers flowing through permafrost, seasonal lakes that appear and disappear based on subtle temperature changes, and rock formations that seem to move on their own across the valley floors, powered by the endless katabatic winds that have shaped this impossible desert for millions of years. Panga Fort, India. Why would the Archaeological Survey of India, a government organisation that studies ancient monuments with scientific precision, officially ban entry to a historical site after sunset? This isn't some local superstition or tourist gimmick. This is India's premier archaeological authority, placing legal restrictions on a 16th century fort based on what they diplomatically call safety concerns. But everyone knows the real reason. Banga Fort in Rajasthan is officially considered the most haunted place in India. The question that has puzzled investigators for decades is simple yet profound. Is there something genuinely supernatural happening within these crumbling walls? Or can science explain why this abandoned palace has become the centre of India's most enduring ghost story? The mystery begins with the fort's abrupt abandonment. Bhangar was once a thriving city of 10,000 people, built in 1573 by Raja Bhagwant Das for his younger son. The fort complex included elaborate palaces, temples and markets that served a bustling community for over 2 centuries. Then, sometime in the early 1700s, the entire population simply vanished. Not fled, vanished. No historical records document a plague, invasion, or natural disaster that could explain such a complete abandonment. Local legends offer their own explanation, centered around 2 compelling theories that have shaped the investigation for generations. The first involves Princess Ratnavati, renowned as one of the most beautiful women in all of Rajasthan. According to this account, a tantric named Singhia became obsessed with the princess and used black magic to try to win her love. When she discovered his deception, she destroyed the magical oil he had enchanted, causing it to turn into a boulder that crushed Singhia to death. With his dying breath, the tantric cursed Banga, dooming the city to abandonment and ensuring that no one could ever live there again. The second theory involves a different kind of curse, this one from a holy man named Baba Balu Nath, who had meditated in the area before the fort was built. He supposedly gave permission for construction on one condition: the buildings must never cast shadows on his sacred meditation spot. When later additions to the fort violated this agreement, Baba Balu Nath cursed the entire settlement, prophesying its complete destruction. These competing legends might seem like simple folklore, but they raise an important question for investigators. Why did an entire thriving city become permanently uninhabitable? Historical records from the Mughal period show that Bhangar paid regular taxes until the early 1700s, then simply disappears from all administrative documents. No other explanation exists in the historical record. Modern paranormal investigators have brought scientific instruments to Bhangar, seeking measurable evidence for the supernatural claims. Teams using electromagnetic field detectors have reported unusual readings throughout the fort complex, particularly in the areas identified with the most intense ghostly activity. Temperature sensors have recorded unexplained cold spots in specific rooms, sometimes showing temperature drops of 15 to 20 degrees Fahrenheit with no apparent environmental cause. Audio recording equipment has captured what investigators claim are voices speaking in languages that don't match any regional dialects. Video surveillance has documented unexplained light anomalies and what appear to be moving shadows in areas where no people were present. Some investigators report electronic equipment malfunctioning specifically within the fort's boundaries, with cameras draining batteries at accelerated rates and GPS devices losing signal even in areas with clear sky visibility. However, skeptical researchers offer alternative explanations for these phenomena. The electromagnetic readings could result from the fort's position on mineral-rich geological formations that naturally create magnetic anomalies. The Aravalli Hills, where Bhangar sits, contain significant iron ore deposits that can interfere with sensitive electronic equipment. Temperature variations might result from the complex airflow patterns created by the fort's architectural design, which includes underground chambers and multiple courtyards that could create microclimate effects. The audio anomalies face similar scientific scrutiny. Sound carries differently through ancient stone structures, and the fort's acoustics could amplify and distort distant sounds from the surrounding villages, creating the impression of voices where none exist. The visual anomalies captured on camera might result from the interaction between digital sensors and the specific lighting conditions created by the fort's orientation and the reflective properties of its weathered stone surfaces. Archaeological evidence provides another layer to the investigation. Excavations around Bhangar have revealed that the site was abandoned suddenly rather than gradually. Personal belongings, cooking utensils, and valuable items were left behind, suggesting the inhabitants fled quickly rather than planning a move. This supports the idea that something catastrophic happened, but it doesn't necessarily prove supernatural involvement. Geological surveys of the area have identified several features that could contribute to the fort's eerie reputation. Underground water channels create acoustic effects that could be interpreted as ghostly sounds. The region sits on a seismically active zone where minor earth movements create settling sounds in the ancient masonry. The combination of these natural phenomena with the power of suggestion could explain many of the reported supernatural experiences. The Archaeological Survey of India's official position remains diplomatically neutral. Their ban on nighttime entry cites safety concerns related to the structural integrity of the ancient buildings and the presence of wild animals in the area. However, internal ASI documents reference the cultural sensitivity of the location and acknowledge the strongly held local beliefs about the fort's supernatural properties. This careful language suggests that while ASI doesn't officially endorse the haunting claims, they recognize the site's unique status in local culture and the potential safety issues that arise from visitors seeking paranormal experiences. Recent investigations have focused on psychological factors that might contribute to the Bhangra phenomenon. The fort's isolated location, crumbling architecture, and reputation create powerful suggestion effects that can influence visitor experiences. The human brain's tendency to interpret ambiguous sensory input as familiar patterns, a phenomenon called pareidolia, could explain why people see faces in shadows or hear voices in wind sounds. Environmental factors also play a role in the ongoing investigation. Bhangra's location creates unique atmospheric conditions, particularly during certain times of day and seasons. The interaction between warm air rising from the valley floor and cooler air descending from the surrounding hills creates thermal layers that can bend light and sound in unusual ways, potentially creating the optical and auditory effects that visitors interpret as supernatural. The investigation has also examined the social dynamics that sustain the Bhangra legend. Local guides and tourism operators have economic incentives to maintain the fort's reputation as a haunted location. The stories become more elaborate with each telling, and new details get added based on visitor reactions and expectations. This doesn't necessarily mean the guides are being deliberately deceptive. They might genuinely believe the stories they tell, having grown up hearing them and witnessing the effects they have on visitors. Research into similar abandoned historical sites worldwide reveals patterns that help contextualize the Bhangra mystery. Many suddenly abandoned settlements develop supernatural reputations, particularly when the reasons for abandonment are unclear or traumatic. The human mind seems to require explanations for inexplicable events, and supernatural theories often fill the gaps left by absent historical records. Skeleton Coast, Namibia, 65 million years ago, when dinosaurs still roamed the earth, the seeds of one of the world's most treacherous coastlines were already being planted. Deep beneath what would become the South Atlantic Ocean, tectonic forces were reshaping the ocean floor, creating conditions that would eventually turn a stretch of African coast into history's greatest ship graveyard. The story begins with the formation of the Benguela Current, a massive river of cold water flowing northward along Africa's western coast. As the supercontinent Gondwana broke apart and the Atlantic Ocean widened, this current established itself as one of the most powerful oceanic conveyor belts on the planet. The cold Antarctic waters it carried northward would become the foundation of an ecosystem and the architect of countless maritime disasters. By the time early humans first walked along this coastline, the Benguela Current had already been sculpting the landscape for millions of years. The cold waters created a temperature inversion that trapped moisture in thick fog banks, while simultaneously supporting one of the richest marine ecosystems on Earth. But the same conditions that made these waters teem with life also made them invisible death traps for sailors. The Namib Desert, pushed inland by the moisture-stealing effects of the cold current, advanced toward the sea over millennia. Sand dunes marched westward like a slow-motion army, creating a landscape where desert met ocean in one of the most hostile environments on the planet. By the time humans developed the technology to venture onto these waters, the stage was set for catastrophe. In 1486, Portuguese explorer Diogo Tau became the first recorded European to encounter what would later be known as the Skeleton Coast. His expedition, following the African coastline in search of a sea route to India, made landfall near present-day Cape Cross. Tau erected a stone cross at Padrão to mark Portuguese territorial claims, but his brief stop revealed the treacherous nature of this coast. Tau's sailors reported waters that appeared and disappeared in curtains of fog, so thick they could barely see the length of their own ship. Compass readings became erratic near the shore, influenced by magnetic anomalies in the iron-rich coastal rocks. Most ominously, they found evidence of previous disasters, pieces of worked wood and ship fittings scattered along beaches where no trees grew and no people lived. The 16th and 17th centuries brought increased maritime traffic as European powers established trade routes around Africa's southern tip. With more ships came more disasters. The Portuguese navigators who followed Sau's route coined the name Costa da Morte, Coast of Death, as reports filtered back of vessels that simply vanished in the fog banks that perpetually shrouded this stretch of coastline. Dutch sailors of the 17th century left more detailed accounts of the coast's dangers. Their ship logs describe fog so dense it muffled sound and disoriented experienced navigators. They wrote of compass needles spinning wildly near shore, and of currents that seemed to flow in impossible directions. Most terrifying were their descriptions of ships that appeared and disappeared like ghosts in the mist, some listing heavily, others showing no signs of life aboard. The mechanism of destruction along the skeleton coast follows a predictable pattern that maritime historians have reconstructed from centuries of disaster reports. Ships approaching from the northwest encounter the Benguela Current, which deflects them towards shore while simultaneously generating the fog that blinds navigation. As vessels struggle to determine their position in the perpetual mist, they're driven steadily towards shore by onshore winds and currents. The coastline itself offers no mercy to ships in distress. Unlike tropical coasts with protected bays and sandy beaches, the skeleton coast presents an almost unbroken wall of surf and sandbar. Ships that manage to avoid immediate destruction on the rocks find themselves stranded on sandy shoals, where the relentless surf pounds them to pieces while the crew faces the prospect of walking across one of the world's most hostile deserts. The early 19th century marked the beginning of the skeleton coast's most deadly period. Steam-powered vessels with their deeper drafts and reduced maneuverability proved even more vulnerable than sailing ships to the coast's hazards. The wreck of the Tally-Ho in 1830 established a pattern that would repeat dozens of times over the next century. Ships disabled by mechanical failure in heavy fog, driven ashore by currents they couldn't escape, and crews forced to choose between the certainty of desert death and the slim hope of rescue from the sea. The industrial age brought larger ships carrying more valuable cargoes, making each disaster more significant. The steel steamship Atavi, wrecked in 1945, carried a cargo of copper and zinc worth millions in today's currency. The crew survived the initial grounding but faced the impossible task of crossing 200 miles of waterless desert to reach civilization. Only half survived the journey, leaving behind a trail of graves that still marks their desperate path inland. But no single disaster captures the horror of the skeleton coast like the loss of the Dunedin Star in November 1942. This British cargo liner, carrying 106 passengers and crew from Britain to South Africa, struck a submerged reef in heavy fog during the early morning hours of November the 29th. The ship held together long enough for everyone to reach shore, but their salvation quickly became their doom. The 106 survivors found themselves stranded on a beach backed by endless sand dunes, with no fresh water and minimal supplies salvaged from their rapidly breaking up ship. Rescue attempts turned into additional disasters as aircraft sent to drop supplies crashed in the soft sand, and ships attempting offshore rescues ran aground themselves. The British destroyer HMS Winchester became another victim of the coast, wrecking while trying to reach the Dunedin Star survivors. The rescue operation stretched across 2 months and ultimately required overland expeditions, using trucks and aircraft to extract the survivors. By the time the last person was rescued, the Dunedin Star disaster had claimed multiple ships, several aircraft, and numerous lives among both survivors and rescuers. The wreck itself disappeared beneath the sand within a few years, leaving only scattered metal fragments to mark one of maritime history's most complex rescue operations. The geological processes that created the skeleton coast continue to shape its deadly reputation. The Benguela Current maintains the temperature differential that generates the persistent fog banks. Tectonic activity along the continental margin creates magnetic anomalies that affect compass readings. Most importantly, the desert continues its westward advance, burying the evidence of maritime disasters beneath moving sand dunes. Modern archaeological surveys using ground-penetrating radar have revealed the true extent of the coast ship graveyard. Beneath the sand dunes lie the remains of vessels spanning 5 centuries of maritime history. Some wrecks sit completely buried under 30 feet of sand preserved in pristine condition by the dry desert environment. Others emerge periodically as shifting dunes expose and then rebury different sections of coastline. The Eduard Bohlen, a German cargo ship that ran aground in 1909, demonstrates the desert's relentless advance. When the ship first wrecked, it sat in shallow water just offshore. Today, the wreck lies nearly 400 meters inland, completely surrounded by sand dunes. The desert didn't just claim the ship, it claimed the sea itself, turning a maritime disaster into a monument rising from the desert floor. Climate change has begun to alter the ancient patterns that made the skeleton coast so deadly. Rising ocean temperatures are weakening the Benguela current and reducing the temperature differential that creates the persistent fog. Paradoxically, this may be making the coast slightly safer for navigation, while simultaneously disrupting the marine ecosystem that has supported coastal wildlife for millions of years. Today, the skeleton coast attracts adventure tourists and researchers rather than cargo ships. Modern GPS navigation and satellite weather monitoring have largely eliminated the navigation hazards that claimed so many vessels. Socotra Island, Yemen. Trees that bleed red resin when cut, flowers that bloom in shapes found nowhere else on Earth, insects that exist only on this single island, birds that sing songs unknown to the rest of their species. Welcome to Socotra Island, where evolution took a completely different path and created what scientists call the most alien-looking place on Earth. In the middle of the Arabian Sea, 240 miles south of Yemen's mainland, sits an island that shouldn't exist. Not because of its geography, plenty of islands dot the world's oceans, but because of what lives there. Nearly 1/3 of its plant species exist nowhere else on the planet. Its trees look like something from a Dr. Seuss book. Its landscapes are so bizarre that when the first photographs reached Europe in the 20th century, scientists thought they had been doctored. The mystery begins with a simple question. How did an island create an ecosystem more unique than entire continents? The story of Socotra's alien garden begins 165 million years ago, when the supercontinent Gondwana started breaking apart. As tectonic forces tore the ancient landmass into pieces that would become Africa, India, Antarctica, and Australia, a small fragment was left behind in what would become the Arabian Sea. This fragment carried with it the genetic blueprints of Gondwana's ancient life forms, setting the stage for one of evolution's most spectacular experiments in isolation. For the next 20 million years, Socotra drifted slowly northward as the Arabian Sea opened wider. The island's cargo of primitive plants and animals found themselves cut off from the evolutionary pressures and genetic exchanges that were reshaping life on the mainlands. Without competition from more advanced species, and without the genetic refreshment that comes from interbreeding with mainland populations, Socotra's life forms began evolving along completely independent pathways. The first written record of Socotra's strangeness comes from an unlikely source, Marco Polo. In the 13th century, the famous Venetian explorer described the island as a place where enchanters and sorcerers lived among trees that produced a red substance more valuable than gold. What Polo had encountered were the dragon's blood trees, Dracaena cinnabari, whose umbrella-shaped canopies and crimson resin seemed so alien that medieval Europeans could only explain them through magic. Polo's account of the red resin trade reveals that Socotra's unique biodiversity was already being exploited commercially 7 centuries ago. The dragon's blood resin was prized throughout the ancient world for its supposed medicinal properties and its use as a red dye. Roman physicians prescribed it for everything from wounds to respiratory ailments. Chinese doctors incorporated it into traditional medicine formulas. The demand was so high that Socotra became a crucial stop on medieval trade routes, its alien trees funding entire economies. But the dragon's blood trees were just the beginning of Socotra's biological mysteries. Portuguese navigators of the 16th century reported forests of bottle-shaped trees that looked more like architectural monuments than living plants. They described flowers that grew directly from rock faces and birds that had forgotten how to fly. Their accounts were so fantastic that European naturalists dismissed them as sailors' tales until the first scientific expeditions proved them true. The breakthrough in understanding Socotra's uniqueness came in the early 20th century, when systematic biological surveys revealed the true scope of the island's endemism. Of the 825 plant species documented on Socotra, 307 exist nowhere else on Earth. That's a 37% endemism rate, higher than the Galapagos Islands, higher than Madagascar, higher than any other island ecosystem of comparable size. The trees alone tell the story of evolution run wild. The desert rose, Adenium obesum socotranum, grows into massive bottle-shaped trunks that can store water for years. During flowering season, these alien-looking trees explode with bright pink flowers that seem to emerge directly from the rock itself. The cucumber tree, Dendrosicyos socotranus, represents an entire botanical family found nowhere else. A tree-sized member of the cucumber family that has somehow learned to grow 20 feet tall in one of the world's most arid environments. Scientific investigation of Socotra's ecosystem has revealed the mechanisms behind its alien characteristics. The island's isolation allowed what biologists call adaptive radiation, the process by which a small number of ancestral species diversifies into many different forms to fill available ecological niches. But unlike the Galapagos, where this process produced variations on familiar themes, Socotra's isolation was so complete and so prolonged that it produced entirely new forms of life. Genetic analysis of Socotra's endemic species has revealed their ancient heritage. Many of the island's plants share DNA sequences with species that went extinct on the mainlands millions of years ago. The dragon's blood trees, for example, are genetic relics of a tree family that once spread across much of Africa and Arabia, but survived only on Socotra. The island became a living museum of evolution, preserving life forms that time forgot. The island's unique geology contributed to its biological strangeness. Socotra is built from a mixture of limestone plateaus and granite mountains, creating microclimates that range from desert dry to surprisingly humid. This geological diversity allowed different evolutionary experiments to proceed simultaneously across the island. Plants that might compete for resources on a uniform landscape instead evolved to exploit different elevations, soil types, and moisture regimes. Climate patterns on Socotra follow their own rules, creating growing conditions found nowhere else. The island sits directly in the path of seasonal monsoons that bring intense but brief periods of moisture. Plants evolved to capitalize on these short wet seasons while surviving the long dry periods that follow. The result is a collection of species with growth patterns and survival strategies that seem designed for an alien world. Modern research has revealed that Socotra's endemic species represent evolutionary solutions to problems that don't exist anywhere else. The Socotran fig tree, for example, has evolved to grow in pure limestone, extracting nutrients from rock through chemical processes that botanists are still trying to understand. The island's endemic succulent plants store water in ways that seem to violate the known laws of plant physiology. The animal life on Socotra proves equally alien. The island is home to species of birds that have forgotten how to migrate, lizards that have evolved to eat only endemic plants, and spiders that build webs using silk with chemical properties found nowhere else on Earth. The Socotra sunbird feeds exclusively on the nectar of dragon's blood trees, creating an evolutionary partnership that exists nowhere else on the planet. Recent DNA studies have revealed that some of Socotra's endemic species are so genetically distinct that they represent entirely new branches on the tree of life. The island's chameleons, for example, diverged from their mainland relatives so long ago that they now require their own taxonomic classification. These aren't just new species, they're new forms of life that evolution created in isolation. Climate change now threatens Socotra's alien garden in ways that evolution never prepared it for. Rising temperatures and changing rainfall patterns are stressing species that evolved under stable conditions. The dragon's blood trees, which have survived for millions of years, are now failing to reproduce successfully as their ancient growing conditions disappear. Human activity compounds the threat to Socotra's unique ecosystem. Overgrazing by introduced goats is destroying the habitat that endemic plants require. Development pressure from a growing human population is fragmenting the landscapes where these ancient species have survived. Most critically, the genetic isolation that created Socotra's uniqueness makes its species especially vulnerable to extinction. Once they're gone, they can never be replaced. Conservation efforts on Socotra face the challenge of protecting species that exist nowhere else and follow biological rules that science is still discovering. Traditional conservation methods developed for mainland ecosystems don't necessarily work for species that evolved in complete isolation. Protecting Socotra's alien garden requires understanding forms of life that challenge everything we thought we knew about how evolution works. Current research on Socotra focuses on documenting its biodiversity before it disappears and understanding the evolutionary mechanisms that created such unique life forms. Every new species discovered on the island, and scientists continue to find them regularly, provides clues about how isolation and time can reshape life in ways that seem almost magical. Salar de Uyuni, Bolivia. Imagine walking across the surface of a frozen ocean that stretches beyond the horizon, where the boundary between earth and sky disappears completely. Now imagine that this endless white expanse isn't made of ice at all, but of pure salt, billions of tons of it, crystallized into patterns so perfectly geometric they look like they were designed by an alien intelligence. Welcome to Bolivia's Salar de Uyuni, where the laws of physics create the world's largest natural mirror, transforming a desert into a gateway between two worlds. Salar de Uyuni isn't unique in being a salt flat. These evaporated lake beds exist on every continent except Antarctica. But what makes Bolivia's salt flat extraordinary isn't just its size, though at 4,000 square miles it's larger than some entire countries. What makes it truly alien is its ability to disappear entirely, transforming from a blindingly white desert into a perfect mirror that reflects the sky with such clarity that visitors lose all sense of up and down. Utah's Bonneville Salt Flats share some characteristics with Salar de Uyuni. Both are remnants of ancient lakes. Both consist of nearly pure salt deposits, and both create landscapes so flat and featureless they seem to belong on another planet. The Bonneville Flats cover about 46 square miles and are famous for land speed records, where cars race across the hard-packed salt at speeds exceeding 600 miles per hour. The salt surface there is so smooth and level that the curvature of the Earth becomes visible to the naked eye. But the Bonneville Flats never create the mirror effect that makes Salar de Uyuni famous worldwide. During Utah's brief rainy season, the Bonneville Salt Flats become muddy and impassable, not reflective. The difference lies in the unique combination of factors that exist only in Bolivia's high-altitude desert. Australia's Lake Eyre presents another comparison point. This massive salt lake in South Australia covers nearly 3,700 square miles when full, almost as large as Salar de Uyuni. Lake Eyre fills with water, perhaps once every 8 years, creating Australia's largest lake when conditions are right. During these rare flooding events, it does create spectacular mirror effects similar to those seen in Bolivia. However, Lake Eyre's transformations are unpredictable and brief. The lake fills during rare flood years and then evaporates completely within months, leaving behind a salt-crusted desert. Visitors might wait decades to see Lake Eyre's mirror phase, while Salar de Uyuni creates its reflecting pools reliably every rainy season. The Dead Sea, despite being the most famous salt body in the world, operates under completely different principles. Its extreme salinity, nearly 10 times saltier than the ocean, creates dense brine that makes swimming impossible and preserves objects indefinitely. But the Dead Sea sits in a deep depression and never creates the optical illusions that make salt flats so mesmerizing. Its thick, oily water reflects light poorly and never achieves the glass-like clarity of a thin layer of water over perfectly flat salt. What makes Salar de Uyuni unique among the world's salt flats is the precise combination of geological and climatological factors that exist only in Bolivia's Altiplano. The salt flat sits at 12,000 feet above sea level, where the thin air and intense solar radiation create evaporation rates found nowhere else on Earth. The elevation also means that even small amounts of rainfall spread across the entire surface with minimal variation in depth. The formation of Salar de Uyuni began 40,000 years ago with a series of prehistoric lakes that covered much of the Altiplano. Lake Minchin, the largest of these ancient bodies of water, was roughly the size of modern-day Lake Titicaca. As the climate changed and became more arid, these lakes began to shrink and concentrate their dissolved minerals. Unlike most evaporating lakes, which leave behind varied mineral deposits, the Altiplano's unique geology created nearly pure salt accumulations. The process that created this purity involved multiple cycles of flooding and evaporation over thousands of years. Each time the ancient lakes filled with water from mountain runoff, they dissolved salt and other minerals from the surrounding volcanic rocks. As the water evaporated, it left behind increasingly concentrated brine. The final stages of this process created what geologists call a salt desert, a landscape where salt crystals form the actual ground surface. The salt crust of Salar de Uyuni averages between 3 and 6 feet thick, but beneath this surface lies something even more remarkable: a brine layer saturated with lithium, potassium, and other minerals that have become crucial to modern technology. This underground brine contains an estimated 50% to 70% of the world's known lithium reserves, making the salt flat not just a natural wonder, but potentially the most valuable mineral deposit on Earth. The mirror effect that makes Salar de Uyuni famous results from the interaction between this salt crust and the minimal rainfall the region receives during its brief wet season. From December to March, light rains deposit just enough water to cover the salt surface with a thin film, rarely more than a few centimeters deep. Because the underlying salt crust is so perfectly flat, this water spreads evenly across the entire surface, creating what amounts to a 4,000 square mile mirror. The flatness of Salar de Uyuni defies comprehension. Satellite measurements show that the elevation varies by less than 3 feet across the entire salt flat. This makes it flatter than most gymnasium floors and explains why the water layer creates such perfect reflections. Any imperfection in the surface would cause the water to pool unevenly, breaking the mirror effect. The chemistry of the surface water also contributes to the optical phenomenon. The water that covers the salt flat during the wet season is nearly pure, containing almost no suspended particles that would scatter light. This clarity, combined with the uniform depth and the white salt background, creates reflection conditions that approach theoretical perfection. The result is a mirror so flawless that it's used to calibrate satellites and study atmospheric conditions. Temperature dynamics add another layer to Salar de Uyuni's unique characteristics. At 12,000 feet elevation, daytime temperatures can reach 70 degrees Fahrenheit, while nighttime temperatures drop below freezing even during the summer months. These extreme temperature swings affect how the salt crystals form and how the surface water behaves, contributing to the geometric patterns that appear across the salt flat. During the dry season, when the water evaporates, Salar de Uyuni reveals another of its mysteries: perfectly hexagonal salt formations that stretch to the horizon like a giant honeycomb. These geometric patterns result from the crystallization process as the thin water layer evaporates. Salt crystals naturally form hexagonal shapes when they have space to grow without interference, and the vast, unobstructed surface of the salt flat allows this process to occur on a massive scale. The mineral composition beneath Salar de Uyuni's surface tells the story of millions of years of geological processes. The brine that lies below the salt crust contains not just lithium, but also magnesium, potassium, borax, and other minerals that formed through the gradual concentration of volcanic materials. These minerals precipitate in layers, creating an underground stratigraphy that scientists are still working to understand. Modern research on Salar de Uyuni has revealed that the salt flat operates as a complex hydrological system. Groundwater flows beneath the salt crust follow patterns that scientists are mapping using satellite interferometry and ground-penetrating radar. These underground water movements affect how the surface salt crystallizes and may explain some of the geometric patterns that appear across the flat. Climate change threatens to alter the delicate balance that creates Salar de Uyuni's mirror effect. Changes in precipitation patterns could affect the timing and amount of water that covers the salt surface during the wet season. Rising temperatures could increase evaporation rates, potentially shortening the mirror season or eliminating it entirely in some years. The lithium extraction industry now operating on parts of Salar de Uyuni represents both an economic opportunity and a threat to the salt flat's unique characteristics. The process of extracting lithium from the underground brine could alter the groundwater flows that maintain the surface salt crust. Some scientists worry that intensive mining could change the fundamental geology that makes the mirror effect possible. Current monitoring of Salar de Uyuni uses satellite imagery to track changes in the salt flat's surface characteristics over time. These studies show that the mirror effect varies in intensity and duration based on subtle changes in weather patterns, suggesting that this natural wonder operates at the edge of the conditions necessary to create such perfect reflections. Kawah Ijen, Indonesia. Slamet winces as the acrid smoke burns his eyes, but he doesn't stop climbing. His bamboo carrying pole bites into his shoulders as he navigates the rocky path down into the crater, balancing 180 pounds of sulfur chunks that will earn him maybe $8 for a full day's work. At 42 years old, he's been making this journey into the mouth of Kawah Ijen volcano for 15 years, and his lungs already show the damage. The blue flames dancing around him in the pre-dawn darkness are beautiful enough to draw tourists from around the world, but for Slamet they represent something far more immediate: the toxic gases that are slowly killing him and the 200 other men who work in what might be the most dangerous job on Earth. The first time I saw the blue fire I thought it was magic, Slamet says, pausing to catch his breath in the thin poisonous air. Now I know it's just sulfur burning, but magic or not, it pays for my children's school. He adjusts his makeshift gas mask, a cloth soaked in water that provides almost no protection against the sulfur dioxide that fills the crater, and continues his descent toward the lake of acid that has become his workplace. The sulfur mining operation at Kawah Ijen represents the last place on Earth where humans extract this mineral using only hand tools and human labour. For over 50 years, men like Slamet have been making twice-daily trips into an active volcanic crater to chip sulfur deposits from the edges of the world's most acidic lake and carry the chunks out on their backs. It's a job that hasn't changed since it began in 1968, when the Indonesian government established the mine to supply sulfur for the country's growing industrial needs. The historical context of sulfur mining reveals why this ancient trade continues in such extreme conditions. Sulfur has been a valuable commodity for thousands of years, used in everything from gunpowder to medicine to industrial chemicals. Before modern extraction methods, sulfur mining was always dangerous work, whether in the volcanic regions of Sicily, the hot springs of Japan, or the sulfur domes of Louisiana. But nowhere has the combination of volcanic activity, extreme chemistry and human desperation created conditions quite like those at Kawah Ijen. The volcano itself sits in the Ijen caldera complex in East Java, part of a chain of active volcanoes that stretches across Indonesia. Kawah Ijen's crater lake contains 36 million cubic meters of water with a pH near zero, making it about as acidic as battery acid. The lake's turquoise colour comes from dissolved sulfur compounds, creating a deceptively beautiful pool that would dissolve human skin within minutes of contact. The blue flames that make Kawah Ijen famous worldwide result from the combustion of sulfuric gases under specific conditions found nowhere else on Earth. Deep beneath the crater, magma heats groundwater and sulfur-rich rocks, creating sulfur dioxide gas that rises through cracks in the volcanic system. When this gas emerges from fumaroles around the crater rim, it encounters oxygen in the air and ignites, burning at temperatures exceeding 1,100 degrees Fahrenheit. The blue colour occurs because of the specific chemistry of burning sulfur. When sulfur combusts, it produces sulfur dioxide and releases energy that excites electrons within the sulfur atoms. As these electrons return to their normal energy state, they emit light in the blue-violet spectrum. The intensity of the blue flames at Kawah Ijen results from the unusually high concentration of sulfur gases, some of the highest levels ever recorded at any volcano. But the same chemical processes that create this natural wonder also make the crater one of the most toxic environments on Earth. Sulfur dioxide gas, even in small concentrations, causes severe respiratory irritation, eye burns and lung damage. The miners work in concentrations that would be immediately fatal in most industrial settings, protected only by inadequate cloth masks and their own desperate need to earn a living. The mining process itself defies modern safety standards in every possible way. Miners arrive at the crater rim at 2 a.m, when the cool night air causes the blue flames to be most visible and when sulfur gas concentrations are theoretically at their lowest levels. They descend 200 meters into the crater, using narrow paths cut into the volcanic rock, carrying bamboo poles and metal tools that would look familiar to sulfur miners from centuries past. At the crater floor, near the shore of the acid lake, sulfur gases emerge from fumaroles at temperatures hot enough to melt the metal pipes that miners insert to direct the gas flow. As the hot sulfur gas cools and condenses, It forms bright yellow deposits that the miners break apart with crowbars and load into wicker baskets. The work requires them to stay within meters of gas vents that emit concentrations of sulfur dioxide that would trigger immediate evacuation procedures at any industrial facility. The physical toll on the miners becomes apparent within years of starting the work. Most suffer from chronic respiratory problems, including severe coughing, shortness of breath, and frequent lung infections. Many develop a condition locally known as sulfur lung, characterized by scarred lung tissue and reduced breathing capacity. The average working life of a Kawaiian miner is less than 10 years, not because they choose to retire, but because their health fails to the point where they can no longer make the arduous climb out of the crater while carrying heavy loads. Sunato, a 41-year-old miner who has worked at Kawaiian for 12 years, exemplifies both the determination and the health consequences of this work. "I cough blood sometimes, especially after a long day in the crater," he explains while resting at the crater rim. "My wife tells me to find other work, but what else can I do? I have no education, no other skills. The sulfur mine pays better than farming or construction work, even if it's killing me slowly." The economic calculations that drive men to work in such conditions reflect the limited opportunities available in rural East Java. A miner who can make 2 trips per day into the crater, carrying out 180 pounds of sulfur each time, can earn between 50,000 and 80,000 rupiah, roughly $6 to $8. In a region where the average daily wage for agricultural work is less than $3, the sulfur mine represents one of the few opportunities for men to earn enough money to support their families. The sulfur extracted from Kawaiian supplies Indonesia's chemical industry, where it's processed into sulfuric acid for fertilizer production, oil refining, and various industrial processes. The irony is stark. While modern industrial facilities use sophisticated safety equipment and automated systems to handle sulfur compounds, the raw material is still extracted by men working with hand tools in conditions that haven't changed since the Industrial Revolution. Recent studies of air quality inside the Kawaiian crater have measured sulfur dioxide concentrations up to 100 times higher than levels considered safe for human exposure. Researchers using industrial-grade gas monitors and protective equipment can spend only minutes in the areas where miners work for hours at a time. The long-term health effects of such exposure are well documented in medical literature, but for the miners, the immediate need to earn money outweighs concerns about future health problems. The social dynamics surrounding the mine reveal how economic desperation perpetuates dangerous working conditions. Most miners come from villages around the volcano where agricultural opportunities are limited and industrial development has bypassed rural communities. The sulfur mine offers one of the few sources of cash income, creating a situation where men knowingly risk their health because the alternative, poverty and hunger for their families, seems worse than the certain prospect of lung disease. Environmental monitoring of the Kawaiian area shows that the volcanic system is becoming more active, with increased gas emissions and higher temperatures in the crater lake. These changes make the mining work even more dangerous, but they also make the sulfur deposits more abundant and easier to extract. The miners have developed an intimate knowledge of the volcano's moods, recognizing subtle changes in gas emissions, flame patterns, and lake color that indicate when conditions are most hazardous. Recent efforts by advocacy groups to improve working conditions at Kawaiian have met with mixed results. Attempts to provide better protective equipment often fail because proper respirators are too expensive for miners to maintain and replace. Proposals to mechanize the sulfur extraction process founder on the economic reality that human labor remains cheaper than investing in equipment that could operate in such a corrosive environment. Tourism has brought global attention to both the blue flames and the miners' plight, but it has also created new complications. Visitors now pay guides to witness the pre-dawn spectacle of blue fire, sometimes inadvertently interfering with mining operations. The contrast between tourists equipped with expensive cameras and protective gear and miners working in the same toxic environment with minimal protection highlights the global inequalities that make such dangerous work economically necessary. The miners themselves have mixed feelings about the attention their work receives. Some appreciate that tourism brings additional income to their communities through guide services and hospitality. Others resent being photographed as objects of curiosity, while they struggle to breathe in conditions that would hospitalize most visitors within minutes. Danakil Depression, Ethiopia. 30 million years ago, the Earth began tearing itself apart in what is now northeastern Africa. 3 massive tectonic plates, the African, Arabian and Somali plates, started pulling away from each other with geological violence that continues to this day. As these continental-sized pieces of the planet's crust separated, they created a wound in the Earth that would eventually become the most hostile environment on the planet's surface, the Danakil Depression, where temperatures regularly exceed 125 degrees Fahrenheit, where the ground is made of salt and sulfur, and where the very air is toxic to breathe. The geological forces that created this hellscape began with the breakup of the supercontinent Pangaea, but the Danakil Depression story truly starts 30 million years ago when the Afar Triple Junction began forming. This is the only place on Earth where 3 tectonic plates meet and actively pull apart from each other on dry land. As the plates separated at a rate of about 1 centimetre per year, roughly the speed at which fingernails grow, they created a triangular depression that would become a natural laboratory for studying how oceans are born. 25 million years ago, the separation had progressed enough to create a substantial rift valley. The Arabian plate was pulling away from the African plate, creating what would eventually become the Red Sea. Simultaneously, the Somali plate was separating from the African plate, forming the early stages of the East African Rift System. At the junction of these 3 pulling forces, the land began to sink below sea level, creating the foundation for one of the most extreme environments on Earth. The Danakil Depression's descent below sea level began about 15 million years ago. As the land sank, the Red Sea occasionally flooded into the depression, creating temporary lakes that would evaporate under the intense heat, leaving behind thick layers of salt and other minerals. This cycle of flooding and evaporation repeated dozens of times over millions of years, creating salt deposits over 1,000 feet thick in some areas. 5 million years ago, the depression had sunk to its current depth of 410 feet below sea level, making it the second lowest point on Earth's land surface after the Dead Sea. By this time, the combination of extreme depth, proximity to the equator, and the heat generated by ongoing tectonic activity had created a climate so harsh that it challenged the very limits of life on Earth. The geological violence that shaped the Danakil Depression also created its most infamous feature, the Dalol hydrothermal field. About 1 million years ago, magma intrusions began heating groundwater beneath the salt deposits, creating a hydrothermal system unlike anything else on the planet. The hot water, enriched with dissolved minerals from the salt deposits, began erupting through the surface, creating an alien landscape of colourful mineral formations. The recent geological history of Dalol reads like a recipe for creating hell on Earth. 50,000 years ago, volcanic activity intensified in the region, adding sulfur compounds and other toxic minerals to the already hostile environment. The combination of extreme heat, acidic water, and poisonous gases created conditions that exist nowhere else on the planet's surface. The formation of the modern Dalol landscape began about 1,000 years ago when increased hydrothermal activity created the colourful salt formations that make the area famous today. Hot, mineral-rich water began erupting through this salt crust, creating a constantly changing landscape of yellow, green, and orange deposits. The water temperatures at these springs can reach 220 degrees Fahrenheit, hot enough to cause third-degree burns instantly. The chemistry of Dalol springs represents one of the most extreme environments known to science. The pH levels can drop as low as -1.5, making the water more acidic than concentrated sulfuric acid. The springs contain dissolved iron, sulfur, chlorine, and dozens of other elements in concentrations that would be immediately lethal to most forms of life. The air above the springs is filled with hydrogen sulfide and other toxic gases that can cause unconsciousness within minutes. In the 20th century, commercial salt mining began in the Danakil Depression, bringing the first regular human presence to this hostile environment. The mining operations revealed the true extent of the area's mineral wealth. Not just salt, but potash, sulfur, and other valuable compounds created by millions of years of evaporation and hydrothermal activity. However, the extreme conditions made mining operations dangerous and difficult to sustain. The 1960s marked a turning point in scientific understanding of the Danakil Depression, when researchers began systematic studies of the area's geology and climate. Temperature measurements confirmed that this was one of the hottest places on Earth year-round, with average annual temperatures exceeding 95 degrees Fahrenheit and daily highs regularly reaching 125 degrees. The humidity levels, despite the extreme heat, often approach 90% due to evaporation from the hot springs, creating a suffocating atmosphere that makes the heat even more unbearable. Detailed geological surveys in the 1970s revealed that the Danakil Depression is essentially a preview of how new oceans form. The spreading seafloor geology normally hidden beneath miles of seawater is exposed here on dry land, allowing scientists to study oceanic processes in an accessible environment. The area represents the youngest oceanic crust on Earth, providing insights into how the Atlantic and Pacific Oceans formed millions of years ago. The 1990s brought increased scientific attention to Dalol when researchers realized that life forms were surviving in conditions previously thought to be absolutely sterile. Bacteria were discovered living in springs with temperatures exceeding 200 degrees Fahrenheit and pH levels that would dissolve human skin. These extremophile organisms challenged fundamental assumptions about the limits of life and opened new possibilities for understanding how life might exist on other planets. Recent research has revealed that the Danakil Depression is becoming even more extreme. Tectonic activity continues to pull the region apart, increasing volcanic activity and creating new hydrothermal vents. Climate change has intensified the already brutal heat, with temperatures now regularly exceeding 130 degrees Fahrenheit during summer months. The combination of rising temperatures and increased volcanic activity is creating conditions that may soon become too extreme, even for the hardy extremophile bacteria that currently call this place home. Modern monitoring stations in the Danakil Depression record environmental conditions that seem more suited to another planet than to Earth. Ground temperatures can exceed 160 degrees Fahrenheit, hot enough to cook food. The air contains concentrations of toxic gases that would trigger immediate evacuation procedures at any industrial facility. Yet somehow, this landscape continues to support microscopic life forms that have adapted to conditions that would kill virtually any other organism on Earth. The geological processes that created the Danakil Depression continue to operate today, making this one of the most geologically active places on the planet. The 3 tectonic plates are still pulling apart, widening the depression by about 1 centimeter per year. Volcanic activity is increasing, with new fissures and hydrothermal vents appearing regularly. Scientists estimate that within 10 million years, the separation will be complete enough for the Red Sea to permanently flood the depression, creating a new ocean in the heart of Africa. Today, the Danakil Depression serves as Earth's closest analogue to the surface conditions that might exist on other planets. NASA and other space agencies study the area's extremophile bacteria to understand how life might survive in the harsh environments of Mars or the moons of Jupiter and Saturn. The chemical processes occurring in Dalol Springs mirror reactions that might occur in the subsurface oceans of Europa or Enceladus. The depression now attracts small numbers of adventure tourists and scientists, but remains one of the most dangerous places on Earth for human visitors. The combination of extreme heat, toxic gases, and unstable ground makes every expedition a carefully planned operation. Visitors must carry their own oxygen supplies and can spend only minutes at a time near the most active hydrothermal features. Climate monitoring data shows that conditions in the Danakil Depression are continuing to worsen, with recent years setting new records for both temperature and toxicity levels. The ongoing geological processes that created this hellscape show no signs of slowing down, ensuring that the Danakil Depression will remain Earth's most hostile environment for millions of years to come, a preview of planetary conditions so extreme they challenge our understanding of where life can exist. Poveglia Island, Italy. Is it possible for an island's soil to be composed of 50% human ash? This extraordinary claim has been repeated countless times about Poveglia Island, a small piece of land in the Venetian lagoon that has earned the reputation as one of the most haunted places in the world. But when we examine this assertion carefully, we uncover a mystery that goes beyond ghost stories. How did a 17-acre island become the centre of one of history's most persistent and disturbing legends? The investigation into Poveglia's true nature begins with competing theories about what actually happened on this island over the centuries. The popular narrative claims that for over 100 years, from the 14th century through the 18th century, Poveglia served as a mass burial ground for plague victims. According to this version, over 160,000 people died on the island, their bodies burned in massive pyres that supposedly left the soil permanently contaminated with human ash. A second theory suggests that while Poveglia did serve as a quarantine station during various plague outbreaks, the scale of death and cremation has been dramatically exaggerated by modern storytellers. This version acknowledges the island's use for plague containment, but questions whether the numbers of dead and the resulting soil composition match the sensational claims that have made Poveglia famous. A third possibility emerges from careful examination of historical records, that Poveglia's reputation as a plague island may be largely based on confusion with other Venetian quarantine stations that did handle large numbers of plague victims. Under this theory, Poveglia's dark reputation represents a case of mistaken identity that has grown into legend over time. To investigate these competing theories, we must examine the historical evidence that documents Venice's response to plague outbreaks. The Venetian Republic faced multiple devastating plague epidemics, most notably in 1348, 1575 to 1577, and 1630 to 1631. Each outbreak killed tens of thousands of people and prompted the city to establish quarantine facilities on various islands in the lagoon. The documented historical record shows that Venice did establish major quarantine stations during these periods, but the primary facilities were Lazzaretto Vecchio and Lazzaretto Nuovo, not Poveglia. Lazzaretto Vecchio, established in 1423, was specifically designed as a plague hospital and isolation facility. Historical records from the Venetian State Archives document its extensive use during plague outbreaks, with detailed accounts of construction, staffing, and patient numbers. Lazzaretto Nuovo, established in 1468, served as a quarantine station for incoming ships and their crews. Archaeological excavations at this site have uncovered clear evidence of mass burials, with organised graveyards containing hundreds of skeletons, arranged in systematic patterns typical of plague burial practices. When we search for similar documentation specifically about Poveglia, the historical record becomes much thinner. While some sources mention the island's use during plague periods, the detailed records that exist for the two main lazarettos are largely absent for Poveglia. This lack of documentation is significant because the Venetian Republic was famous for its meticulous record keeping, especially regarding public health measures. Archaeological evidence provides another avenue for investigation. Systematic excavations at documented plague sites throughout Europe have revealed characteristic patterns: mass graves with bodies arranged in organised layers, evidence of lime treatment to prevent decay, and artefacts associated with medical care. At Lazzaretto Nuovo, archaeologists have found exactly these types of evidence, confirming its use as a major plague facility. However, no similar systematic archaeological investigation has been conducted at Poveglia to verify the claims about mass burials and cremations. The island remains privately owned and largely inaccessible to researchers, making scientific verification of the soil composition claims impossible. Without soil analysis or archaeological excavation, the assertion that 50% of the island consists of human ash remains unverified. The chemistry of the soil composition claim also raises questions. Cremation of human bodies requires sustained temperatures of 1,400 to 1,800 degrees Fahrenheit for 2 to 3 hours per body. Creating the amount of ash that would compose 50% of a 17-acre island's soil would require an industrial-scale cremation operation that would have consumed enormous quantities of fuel and required sophisticated logistics. Historical accounts of plague body disposal in Venice primarily describe burial, not cremation. During major outbreaks, authorities struggled with the logistics of disposing of large numbers of bodies quickly, but the solutions typically involved mass graves, not mass cremation. The few instances of burning plague victims that appear in historical records were emergency measures during the worst periods of specific outbreaks, not systematic practices continued over decades. The timeline of Poveglia's various uses also complicates the mass cremation theory. After its alleged period as a plague island, Poveglia was used for agriculture in the 19th century. Farmers successfully grew crops on the island for decades, which would be unlikely if the soil truly contained the high concentrations of human ash and associated chemicals that mass cremation would produce. From 1922 to 1968, Poveglia housed a mental hospital, and again the facility operated normally with gardens and agricultural activities. Staff lived on the island with their families, and patients spent time outdoors. This long period of normal habitation contradicts claims about the island being too contaminated or spiritually disturbed for human occupation. Modern investigations by paranormal researchers have produced conflicting results. Some groups report unusual electromagnetic readings and temperature anomalies that they interpret as evidence of supernatural activity. However, these same phenomena could result from the island's construction materials, its location in the lagoon, or the power of suggestion affecting researchers who arrive already convinced of the island's haunted reputation. Skeptical investigators who have visited Poveglia report finding bone fragments on the beaches, which believers cite as evidence of the mass deaths. However, bone fragments washing up on islands in the Venetian lagoon is not unusual, given the area's long history of human habitation and the effects of tidal action on old burial sites throughout the region. The growth of Poveglia's reputation as the most haunted place in the world appears to coincide with the rise of internet ghost hunting culture and paranormal tourism. Many of the most specific and frightening details about the island, including the 50% human ash claim, appear to have emerged in the 21st century rather than being passed down from historical sources. Media coverage of Poveglia has often repeated claims without verification, creating a feedback loop where each retelling adds new details or increases the scale of the alleged horrors. Television shows, books and websites have amplified the legend, while rarely examining the historical evidence that might support or contradict the claims. The Italian government's current restrictions on visiting Poveglia contribute to the mystery by making independent investigation difficult. The island is owned by a private foundation and requires special permission for visits, creating an air of secrecy that fuels speculation about what might be hidden there. Recent attempts to purchase or lease Poveglia for development have generated renewed interest in the island's true history. Potential investors would need to conduct environmental assessments that could finally provide scientific analysis of the soil composition. However, these efforts have been complicated by both the island's reputation and bureaucratic obstacles. The ongoing debate about Poveglia represents a broader challenge in separating historical fact from modern legend. In the age of viral information, stories can achieve the status of accepted truth through repetition rather than verification. The island's genuine historical significance, whatever that might be, becomes obscured by sensational claims that serve the needs of entertainment rather than historical understanding. Bermuda Triangle, Atlantic Ocean. For over a century, pilots and ship captains have reported something unsettling about the Bermuda Triangle. Their compasses don't behave the way they should. Some describe needles spinning wildly, others report readings that drift from true north by several degrees, and a few claim their instruments simply stop working altogether. But here's the central question that has puzzled investigators for decades. Is there really something magnetically unusual about this stretch of ocean between Florida, Bermuda and Puerto Rico? Or are we looking at a case where scientific misunderstanding has fueled one of the world's most persistent mysteries? The investigation into the Bermuda Triangle's alleged magnetic anomalies must begin with three competing theories that attempt to explain the reported compass problems. The first theory suggests that the Bermuda Triangle sits over some kind of unique geological formation that creates genuine magnetic disturbances. Proponents of this theory point to reports from experienced navigators who claim their instruments behave differently in this region compared to other areas of the ocean. The second theory proposes that the Bermuda Triangle's reputation for magnetic strangeness stems from a misunderstanding of normal magnetic variation. According to this explanation, the compass problems reported in the area are no different from those encountered anywhere else on Earth, but they've been misinterpreted by people who don't understand how magnetic declination works. The third theory suggests that the magnetic anomaly claims are largely mythical, based on a combination of normal navigation errors, equipment failures, and the human tendency to attribute unexplained events to mysterious forces. Under this theory, the Bermuda Triangle's magnetic reputation exists primarily in popular culture, rather than in measurable scientific reality. To evaluate these competing theories, investigators must first understand how Earth's magnetic field actually works. The planet acts like a giant magnet, with magnetic field lines extending from the magnetic North Pole to the magnetic South Pole. However, the magnetic poles don't align perfectly with the geographic poles. They're offset by about 11 degrees and constantly moving due to changes in the Earth's molten iron core. This offset creates what navigators call magnetic declination, or compass variation, the difference between magnetic north, where a compass points, and true north, the actual geographic North Pole. The amount of declination varies depending on your location on Earth, and it changes over time as the magnetic poles drift. In some places, the declination can be as much as 30 degrees or more. The key to understanding the Bermuda Triangle's magnetic reputation lies in a phenomenon called the agonic line, an imaginary line on Earth's surface where magnetic declination is zero. Along this line, magnetic north and true north align perfectly, so a compass points directly toward the geographic North Pole without any correction needed. Historical records show that the agonic line did pass through the Bermuda Triangle region for much of the 20th century. This created a situation where navigators accustomed to making declination corrections in other parts of the world would find their compasses pointing to true north without adjustment when they entered this area. For someone unfamiliar with magnetic declination, this could seem like strange or supernatural behavior. However, the agonic line is not stationary. As Earth's magnetic field changes, the line moves across the planet's surface. Modern magnetic surveys conducted by the National Oceanic and Atmospheric Administration show that the agonic line has shifted westward and no longer passes through the Bermuda Triangle. Today, the magnetic declination in the Bermuda Triangle region is similar to that found in comparable latitudes elsewhere. When we examine specific cases often cited as evidence of magnetic anomalies in the Bermuda Triangle, alternative explanations emerge. The famous disappearance of Flight 19 in December 1945 is frequently attributed to compass malfunctions, but radio transcripts from the flight reveal that the squadron leader became confused about his location and may have been flying in the wrong direction for hours before the planes ran out of fuel. The flight instructor, Lieutenant Charles Taylor, was heard on radio saying his compasses were going crazy, but investigators noted that he was flying over an area where magnetic declination would have been close to zero, meaning his compasses were actually working correctly, but he may not have understood why they were pointing differently than he expected based on his experience in other regions. Scientific investigations of the ocean floor beneath the Bermuda Triangle have found no unusual geological formations that would create magnetic anomalies. The seabed consists of typical sedimentary deposits and limestone formations common throughout the Caribbean and Western Atlantic. While some areas do contain iron-rich minerals that could theoretically affect compass readings, these deposits are no different from those found in many other ocean regions. Magnetic field measurements taken by research vessels throughout the Bermuda Triangle region show variations that fall well within normal ranges for this part of the Atlantic Ocean. The US Coast Guard and Navy have conducted extensive magnetic surveys of the area as part of routine navigation safety programs, and their data shows no anomalous readings that would pose unusual dangers to navigation. Modern GPS technology has essentially eliminated the navigation problems that may have contributed to the Bermuda Triangle's reputation. Satellite navigation systems don't rely on magnetic compasses and aren't affected by magnetic declination, providing precise position information regardless of local magnetic field variations. The widespread adoption of GPS has coincided with a dramatic decrease in reported navigation problems in the Bermuda Triangle region. However, the investigation reveals that compass problems in the Bermuda Triangle weren't entirely imaginary. During the mid-20th century, when most of the famous disappearances occurred, navigators did encounter situations where their magnetic compasses behaved differently than expected. The key insight is that this wasn't due to supernatural forces or unusual geology, but to the area's position along the agonic line combined with navigators' incomplete understanding of magnetic declination. Equipment failure represents another factor in the magnetic anomaly reports. Saltwater environments are notoriously hard on electronic equipment, and compass systems can malfunction due to corrosion, electrical problems, or mechanical wear. In an era before redundant navigation systems and electronic backups, a single compass failure could leave navigators completely lost, especially in an area where radio communication might be limited. Weather conditions in the Bermuda Triangle region also contribute to navigation challenges that might be misinterpreted as magnetic anomalies. The area experiences frequent thunderstorms, which can create electromagnetic disturbances that temporarily affect sensitive electronic instruments. Rapid weather changes can also create visibility problems that make celestial navigation difficult, forcing greater reliance on potentially unreliable compass readings. The investigation also reveals how confirmation bias has shaped the Bermuda Triangle's magnetic reputation. Once the area became known for compass problems, navigators entering the region may have been more likely to notice and report normal compass variations that they would ignore elsewhere. This created a feedback loop where the area's reputation for magnetic strangeness was reinforced by increased attention to ordinary navigational phenomena. Modern analysis of historical navigation logs from ships and aircraft that traversed the Bermuda Triangle during its peak period of mysterious reputation shows that compass problems were actually reported no more frequently than in other heavily travelled ocean areas. The difference was that problems in the Bermuda Triangle received more attention and were more likely to be attributed to mysterious causes rather than routine equipment issues or human error. The US Navy and Coast Guard maintain official positions that dismiss claims of unusual magnetic activity in the Bermuda Triangle. Their navigation warnings and sailing directions for the area make no mention of magnetic anomalies beyond the standard compass variation information provided for all ocean regions. Military and commercial vessels continue to transit the area routinely, using standard navigation procedures without reporting unusual compass behaviour. Current scientific understanding suggests that the Bermuda Triangle's reputation for magnetic anomalies stems from a combination of factors: the area's historical position along the Agonic Line, limited understanding of magnetic declination among some navigators, normal equipment failures in a harsh marine environment, and the human tendency to attribute unexplained events to mysterious forces. The ongoing debate reflects not the presence of genuine magnetic anomalies, but the persistence of myths that continue to influence public perception despite scientific evidence to the contrary. Dead Sea, Israel, and Jordan. 20 million years ago, tectonic forces began ripping apart the Earth's crust in what would become the Jordan Rift Valley, creating a geological wound that would eventually hold one of the most extraordinary bodies of water on our planet. The African plate was pulling away from the Arabian plate along a massive fault line, stretching and thinning the crust until it formed a deep depression. At this time, the area was connected to the Mediterranean Sea, filled with normal salt water that supported typical marine life. Nothing about this ancient seaway suggested it would become the most alien aquatic environment on Earth. As the Rift Valley continued to deepen over millions of years, periodic connections and disconnections with the Mediterranean Sea created a cycle of filling and evaporation that gradually concentrated the water's mineral content. By 5 million years ago, the depression had evolved into a series of hypersaline lakes, each more concentrated than the last. The process was relentless. Water would flow in, carrying dissolved minerals from the surrounding rocks, then evaporate under the intense Middle Eastern sun, leaving behind ever higher concentrations of salts and other compounds. 3 million years ago, the geological violence that created the Rift Valley had stabilised enough to allow the formation of more permanent water bodies. Lake Amora became the first major hypersaline lake in the depression, lasting for over 1 million years while accumulating salt deposits thousands of feet thick. When climate changes caused Lake Amora to shrink and eventually disappear, it left behind a foundation of nearly pure salt that would become the basement of all future lakes in the basin. The cycle repeated itself again and again over the next 2 million years. Lake Samra formed and evaporated. Lake Sedum came and went. Each successive lake became more concentrated, more hostile to life, and more alien in its chemistry. The depression was becoming a natural laboratory for extreme conditions, evolving toward a state where water could exist, but life could not. About 70,000 years ago, climate conditions changed dramatically, ushering in the era of Lake Lisan, the direct ancestor of today's Dead Sea. Lake Lisan was enormous, stretching over 200 miles from the Sea of Galilee in the north to 30 miles south of the current Dead Sea. This massive lake was fed by significantly greater rainfall than the region receives today, but even then, the water was already too salty to support normal aquatic life. Lake Lisan's story reveals how quickly extreme conditions can develop in the right geological setting. Fed by the Jordan River and seasonal floods, the lake initially maintained some connection to fresher water sources, but the high evaporation rates, caused by the depression's depth below sea level and the region's arid climate, meant that minerals accumulated faster than they could be diluted by incoming fresh water. By 20,000 years ago, Lake Lisan had reached its maximum extent, covering an area larger than some entire countries. The lake's shores were marked by massive terraces of deposited minerals, creating stepped landscapes that remain visible today as evidence of the lake's former size. The water was already approaching the salinity levels that would make the Dead Sea famous, but it would take another dramatic environmental change to push the system over the edge into true extremeness. The end of the last ice age 15,000 years ago triggered Lake Lisan's collapse. As global temperatures rose and rainfall patterns shifted, the lake's sources of fresh water began to diminish while evaporation rates increased. The enormous lake began shrinking rapidly, concentrating its dissolved minerals into ever smaller volumes of water. This wasn't a gradual process. Geological evidence suggests that Lake Lisan lost 2/3 of its volume in less than 5,000 years. By 11,000 years ago, Lake Lisan had contracted to roughly the size and location of the modern Dead Sea, but the concentration process was just beginning. The final transformation from a large, very salty lake to the hyper-extreme environment we know today happened with geological speed. As the water level dropped, the remaining liquid became a brine so concentrated that salt began crystallizing out of solution, forming the massive deposits that characterize the Dead Sea Basin today. The chemistry of this transformation pushed the water beyond the limits of what most people would recognize as a liquid. The salinity reached 10 times that of ordinary seawater, so concentrated that the water became viscous, oily to the touch, and dense enough to easily float the human body. But salinity was just the beginning of the Dead Sea's chemical extremeness. The concentrated brine also contained massive amounts of magnesium, potassium, bromine, and other minerals in concentrations that would be toxic to virtually all forms of life. Human civilizations began encountering this alien sea about 4,000 years ago, when ancient peoples discovered the valuable resources it contained. The Dead Sea produced bitumen natural asphalt that bubbled up from the lake floor and could be harvested from the surface. This bitumen was so valuable that it was traded throughout the ancient world, used for waterproofing ships, embalming bodies, and creating adhesives. The Egyptians called it the Bitumen Sea, and entire economies developed around harvesting its unusual products. Ancient texts describe the Dead Sea as a place where nothing could live and where the water itself seemed unnatural. The Jewish historian Josephus wrote about the lake's remarkable buoyancy and its production of bitumen, noting that objects thrown into the water would resurface on their own. Roman writers described the sea as evidence of divine punishment, a place where the normal laws of nature had been suspended. But it was only in the modern era that scientists began to understand the true extent of the Dead Sea's extremeness. In the 19th century, systematic chemical analysis revealed that the water contained over 30% dissolved minerals, a concentration so high that it approaches the saturation point where no more salt can dissolve. The lake had become essentially a liquid mineral deposit, more similar to industrial brine than to natural water. The 20th century brought industrial exploitation of the Dead Sea's extreme chemistry. Companies began extracting potash, bromine, and other valuable minerals from the concentrated brine, establishing facilities that processed millions of gallons of this liquid mineral resource. The extraction process revealed the true wealth hidden in the Dead Sea's alien waters, reserves of potash and other minerals worth billions of dollars. However, this industrial activity, combined with increased diversion of fresh water from the Jordan River, began accelerating the Dead Sea's decline. By the 1960s, the water level was dropping noticeably as more water was being removed than was flowing in. The sea that had taken thousands of years to reach its current concentration was beginning to shrink at an unprecedented rate. The pace of change accelerated dramatically in the late 20th century. By the 1990s, the Dead Sea was losing more than 3 feet of depth per year. Entire beaches that had existed for decades disappeared underwater as the shoreline retreated. Hotels built near the water found themselves hundreds of yards from the new shore. The northern and southern basins of the Dead Sea became separated for the first time in recorded history. As the 21st century began, the Dead Sea's decline entered a new phase of environmental crisis. The retreating waters left behind unstable salt deposits that began collapsing, creating sinkholes that opened without warning. Roads, buildings, and agricultural areas around the lake became dangerous as the ground literally fell away beneath them. By 2010, over 1,000 sinkholes had appeared around the Dead Sea's perimeter. The sinkhole phenomenon revealed how the Dead Sea's extreme chemistry had affected the surrounding landscape. For thousands of years, hypersaline groundwater had infiltrated the soil and rock around the lake, creating underground chambers supported by salt deposits. As the lake level dropped, fresher groundwater began dissolving these salt supports, causing the surface to collapse into cavities that could swallow entire trees or buildings. Today, the Dead Sea continues to shrink at a rate that scientists describe as catastrophic. The water level drops by more than 4 feet per year, and new sinkholes appear weekly around the shoreline. The northern basin, which historically contained most of the Dead Sea's water, is becoming so shallow that it may eventually split into separate pools. The ecosystem of extreme organisms that had adapted to the Dead Sea's unique conditions is being pushed beyond even their remarkable tolerance limits. Current projections suggest that without intervention, the Dead Sea could lose another third of its volume within the next 50 years. The concentration of its remaining water would increase beyond anything seen in the lake's geological history, potentially creating conditions so extreme that even the specialized bacteria and algae that currently survive in the brine would be eliminated. The Dead Sea, having reached the ultimate expression of aquatic extremeness, now faces the possibility of becoming too extreme even for the life forms that made it their final refuge on Earth. Paektu Mountain, North Korea, and China. You can see it from space. A perfect circle of blue water sitting like a jewel in the crown of a snow-capped mountain. But getting there means crossing one of the most heavily guarded borders on Earth. Welcome to Mount Paektu, where politics and volcanism collide in ways that would be almost comical if they weren't so dangerous. The locals on the Chinese side call it Changbaishan. The Koreans know it as Paektu, but to scientists around the world, this massive stratovolcano represents one of the most intriguing and inaccessible volcanic systems on our planet. Standing 9,003 feet tall, on the border between North Korea and China, it holds secrets that have remained locked away for over 1,000 years. What makes this mountain truly mysterious isn't just its political isolation, it's what happened here in 946 AD. On a November morning over a millennium ago, this peaceful-looking peak unleashed one of the most catastrophic volcanic eruptions in recorded history. The explosion was so violent that it threw ash across an area spanning more than 600 miles. Volcanic debris from this single event has been found in Japan, nearly 800 miles away, and layers of ash appear in ice cores from Greenland on the opposite side of the globe. They call it the Millennium Eruption, and the numbers are staggering. This wasn't just any volcanic blast. Modern analysis of the ash deposits suggests the eruption column reached heights of over 20 miles into the atmosphere, punching through the stratosphere and spreading a blanket of volcanic material across Northeast Asia. The explosion rank as a VEI 7 event, the second highest level on the Volcanic Explosivity Index. To put that in perspective, it was comparable to the 1815 eruption of Mount Tambora in Indonesia, which caused global climate disruption and led to the famous year without a summer. But here's where the story gets complicated. While Tambora's eruption is well documented in historical records worldwide, the Millennium eruption of Mount Paektu occurred in a region where written records were sparse. Ancient Korean and Chinese chronicles mention unusual phenomena around that time. Strange lights in the sky, ash falling like snow in the middle of autumn, and what one record describes as thunder from the earth that lasted many days. For centuries, these historical accounts remained scattered fragments. The mountain itself became even more isolated as political tensions sealed the border. During the Cold War, Mount Paektu essentially disappeared from international scientific study. While volcanologists studied active peaks around the world, this sleeping giant remained off-limits, hidden behind military checkpoints and political barriers. The first hint that something might be stirring came in the early 2000s. Chinese monitoring stations began detecting unusual seismic activity around the mountain. Between 2002 and 2005, the frequency of small earthquakes increased dramatically. Ground-based measurements showed the mountain was actually inflating, pushing upward by several inches as something deep underground appeared to be moving. Temperature readings from hot springs around the crater lake showed increases of several degrees. Gas emissions from volcanic vents changed their chemical composition. All of these signs pointed to one possibility that made scientists around the world extremely nervous. The magma chamber beneath Mount Pektu might be reawakening. This created an unprecedented situation. Here was potentially one of the world's most dangerous volcanoes, showing clear signs of unrest, sitting directly on the border between two countries with virtually no scientific cooperation. The North Korean side of the mountain was completely inaccessible to Western researchers. The Chinese side was monitored, but data wasn't being shared internationally. Dr. James Hammond from Imperial College London faced a challenge unlike any in modern volcanology. How do you study a volcano when half of it is in one of the world's most isolated countries? The answer came through an unlikely channel. North Korean scientists were just as concerned about their sacred mountain as anyone else. Mount Pektu holds deep cultural significance in North Korea. According to official state mythology, it's the legendary birthplace of Kim Jong-il. Though he was actually born in the Soviet Union, the mountain appears on the North Korean coat of arms, and its image is used throughout the country's propaganda. For the North Korean government, the idea of their sacred mountain potentially erupting was both a scientific concern and a political nightmare. In a rare moment of international cooperation, North Korean officials reached out to Western scientists. The message was simple but urgent. They had seismic monitoring equipment, but they needed expertise and more advanced instruments. Would international researchers be willing to collaborate? The logistical challenges were immense. Getting scientific equipment across the North Korean border required navigating layers of bureaucracy that had been in place for decades. Every piece of equipment had to be approved, every measurement protocol had to be negotiated, and every data sharing agreement had to pass through political channels that normally had nothing to do with science. But the scientific stakes were too high to ignore. Modern computer modelling of the Millennium eruption suggests that a similar event today would be catastrophic on a regional scale. The crater lake at the mountain's summit contains over 2 billion tons of water. In a major eruption, this water would instantly flash to steam, creating devastating mudflows that could travel for dozens of miles down the mountain's slopes. The populated areas at risk aren't just small villages. The Chinese city of Changbai, home to hundreds of thousands of people, sits directly in the path of potential pyroclastic flows. Ash from a major eruption would ground air traffic across Northeast Asia, potentially affecting the economies of China, South Korea, and Japan. The region produces a significant portion of the world's electronics, and volcanic ash is particularly damaging to sensitive manufacturing equipment. Recent studies have added another layer of concern. North Korea's nuclear test site at Punggye-ri is located just 60 miles from Mount Pektu. Each underground nuclear test creates seismic waves that travel through the Earth's crust. Some scientists worry that these artificial earthquakes could potentially trigger increased volcanic activity, though the connection remains highly debated in the scientific community. The collaboration that finally emerged was unlike anything seen in modern volcanology. British and American scientists worked alongside North Korean researchers, sharing data from seismometers placed around the mountain's base. The measurements revealed a complex magma chamber system extending deep into the Earth's crust, with partially molten rock at depths of 3 to 6 miles underground. What they discovered was both reassuring and troubling. The magma chamber is indeed active, with evidence of fresh magma injection from deeper sources. However, the system appears to be stabilizing after the unrest of the early 2000s. Seismic activity has decreased, ground deformation has slowed, and gas emissions have returned to more normal levels. But the mountain hasn't returned to complete quiet. Small earthquakes continue to occur regularly, and the crater lake temperature remains elevated compared to historical norms. The volcanic system appears to be in a state of watchful waiting, neither fully dormant nor actively preparing for eruption. The political situation adds another layer of unpredictability. Border tensions between North Korea and China fluctuate with international relations. When diplomatic relations are strained, scientific data sharing stops. When nuclear tests occur, monitoring equipment sometimes gets temporarily relocated for security reasons. The volcano operates on geological timescales, but the humans trying to study it must navigate much shorter political cycles. Today, Mount Pektu remains one of the most closely watched but least accessible volcanoes on Earth. Chinese tourists visit the crater lake in large numbers, taking photos of the pristine blue water surrounded by volcanic peaks. But the North Korean side remains largely off-limits, visited only by specially approved tour groups and the occasional scientific expedition. The mountain continues to hold its secrets. Deep underground, in magma chambers that have been building pressure for over 1,000 years, geological processes continue that could reshape the region. Scientists monitor what they can, sharing data when politics allow, always aware that they're watching a sleeping giant that has already proven it can wake up with devastating consequences. Remote sensing satellites keep constant watch, measuring minute changes in the mountain's shape and temperature. International volcanic alert systems include Mount Paektu in their monitoring networks, despite the challenges of getting real-time data from the secretive North Korean side. The seismic networks continue to detect the mountain's heartbeat, dozens of small earthquakes each year that serve as reminders that the volcanic system remains very much alive. Each tremor is analysed, each gas emission measured, each temperature change recorded in the ongoing effort to understand what might happen next. But perhaps the most remarkable thing about Mount Paektu is how it has forced international cooperation in one of the world's most divided regions. Scientists from countries that barely speak to each other diplomatically have found common ground in their shared concern about this volcanic threat. Yellowstone's Thermal Features USA. David Allen is one of the lucky ones. The 70-year-old photographer was standing on the boardwalk at Grand Prismatic Spring in Yellowstone, adjusting his camera lens to capture the rainbow bands that stretch across the world's third largest hot spring, when his cell phone slipped from his jacket pocket. Instinctively, he lunged forward to catch it, his hand breaking through the wooden railing and plunging toward the steaming water below. The scalding steam alone was enough to send him reeling backward, his palm red and blistered from exposure to air heated to over 160 degrees Fahrenheit. He never got his phone back, but he kept his life. David was inches away from joining the more than 20 people who have died in Yellowstone's thermal features over the past century and a half. The most tragic case happened on a June morning in 2016, when 23-year-old Colin Scott from Oregon walked off the designated boardwalk at Norris Geyser Basin with his sister, looking for a place to illegally soak in one of the park's hot springs. The practice is called hot potting, and despite being strictly forbidden, some visitors still attempt it. Colin knelt down at the edge of an unnamed thermal pool to test the water temperature with his hand. The ground gave way beneath him, and he slipped into water that was not just boiling but laced with sulfuric acid. His sister watched helplessly as her brother disappeared into the churning acidic water. When park rangers arrived hours later, there was nothing left to recover. The extreme heat and acid had completely dissolved his remains. These incidents represent the deadly intersection between human curiosity and one of Earth's most extreme environments. Yellowstone's thermal features aren't just hot water. They're geological windows into processes that have been shaping our planet for billions of years. The park sits atop the Yellowstone caldera, a supervolcano system where magma lies just 2 to 3 miles beneath the surface. This proximity to molten rock creates the largest collection of thermal features on Earth, over 10,000 hot springs, geysers, mud pots and fumaroles that range in temperature from pleasantly warm to lethally hot. The historical record of Yellowstone's thermal hazards stretches back to the earliest European expeditions into the region. In 1870, members of the Washburn-Langford-Doane expedition described the thermal areas as both magnificent and terrifying. Truman Everts, who became separated from the expedition and spent 37 days lost in the wilderness, later wrote about accidentally stepping into thermal runoff that burned through his boot and blistered his foot so severely he could barely walk for days. Early park records from the 1880s document a steady stream of thermal accidents. Visitors weren't just accidentally falling into hot springs, they were deliberately entering them, believing the mineral-rich waters had medicinal properties. An 1888 report describes a man who died after soaking in a hot spring for too long, essentially cooking himself from the outside in. Another account tells of a woman who suffered severe burns after sitting in thermal runoff, not realizing that even the water flowing away from hot springs can maintain scalding temperatures for hundreds of yards. But the same extreme conditions that make these thermal features dangerous to humans have created some of the most remarkable ecosystems on Earth. The brilliant colours that draw millions of visitors to places like Grand Prismatic Spring aren't mineral deposits or optical illusions, They're living communities of microorganisms called thermophiles, heat-loving bacteria and archaea that thrive in conditions that would instantly kill most life forms. In the centre of Grand Prismatic Spring, where temperatures reach 189 degrees Fahrenheit, the water appears deep blue, too hot for any visible life. But as the water flows outward and cools, it creates distinct temperature zones where different species of thermophiles can establish communities. At around 165 degrees, yellow and orange bacteria begin to flourish. As temperatures drop further to 140 degrees, green algae appear. The outermost edges, where water temperatures fall to around 130 degrees, support red and brown microbial mats. These aren't just random colonies of bacteria, they're highly organised communities where different species work together in complex relationships. Some thermophiles photosynthesize like plants, using sunlight to create energy. Others are chemotrophs, feeding off sulfur compounds and other chemicals dissolved in the hot water. Many of these organisms are archaea, a form of life so ancient and primitive that they're considered separate from both bacteria and all other life on Earth. The discovery of thermophiles revolutionized our understanding of life's limits and possibilities. Before scientists began studying Yellowstone's thermal features in detail, during the 1960s, the scientific consensus was that life couldn't survive in water hotter than about 160 degrees Fahrenheit. The thermophiles of Yellowstone shattered that assumption, with some species thriving in water temperatures exceeding 200 degrees. Dr. Thomas Brock's groundbreaking research in Yellowstone during the 1960s and 1970s led to the discovery of Thermus aquaticus, a heat-loving bacterium found in the park's hot springs. This organism produces an enzyme called Taq polymerase, which remains stable at high temperatures. This discovery became the foundation for PCR, polymerase chain reaction, a technique that allows scientists to rapidly copy DNA sequences. PCR technology is now essential for everything from medical diagnostics to criminal forensics to COVID-19 testing. A microorganism living in a Yellowstone hot spring fundamentally changed modern biology and medicine. The extreme acidity of many thermal features adds another layer of danger and scientific fascination. While Grand Prismatic Spring is relatively neutral, other pools in Yellowstone have pH levels below 2, making them more acidic than lemon juice or vinegar. The Norris Geyser Basin, where Colin Scott died, contains some of the most acidic thermal features in the park. These pools get their extreme acidity from hydrogen sulfide gas rising from deep underground, which dissolves in the hot water to form sulfuric acid. Remarkably, even these acid pools support life. Acidithiobacillus species and other extremophile bacteria have adapted to thrive in these harsh conditions, processing sulfur compounds and creating biofilms that can actually increase the acidity of their environment. These organisms are so specialized that they can't survive in normal conditions. They require both extreme heat and extreme acidity to function. The temperatures in Yellowstone's thermal features vary dramatically, creating microclimates that span the full range of thermophile habitats. Some pools maintain constant temperatures year-round, while others fluctuate based on underground water flow and seasonal changes. Geysers create particularly dynamic environments, with temperatures cycling from scalding hot during eruptions to merely warm between eruptions. This temperature variation has allowed scientists to study how thermophile communities respond to environmental changes. When geyser eruptions disrupt established microbial mats, new species quickly colonize the disturbed areas. The succession of different thermophile species during recovery provides insights into how life might adapt to changing conditions on Earth and potentially on other planets. NASA has extensively studied Yellowstone's thermophiles as analogues for possible life on Mars or other planets. The extreme conditions in Yellowstone's thermal features, combined with high radiation levels at elevation, create environments that may be similar to conditions on early Earth or on other worlds. If life can thrive in Yellowstone's acid hot springs, it might also survive in the subsurface oceans of Jupiter's moon Europa or in the hydrothermal systems of Mars. For visitors today, Yellowstone's thermal features represent both wonder and warning. The park's boardwalk system, built and continuously maintained at enormous expense, keeps people at safe distances while still allowing them to witness these remarkable ecosystems. Signs posted throughout the thermal areas carry stark warnings about surface temperatures that can exceed 200 degrees Fahrenheit, about thin crusts that can break under human weight, and about toxic gases that can accumulate in low-lying areas. Yet accidents continue to happen. In 2019, a 17-year-old suffered significant thermal burns after leaving the boardwalk at Norris Geyser Basin. In 2021, a woman was burned when she fell into a thermal feature at Roe, the Old Faithful. Each incident serves as a reminder that these beautiful, colourful pools are fundamentally alien environments where normal rules of safety don't apply. Park rangers estimate that they respond to thermal-related injuries several times each year, most involving visitors who ignore safety barriers or venture off designated trails. The injuries range from minor burns caused by contact with thermal runoff to severe scalding from direct contact with hot springs. The remote location of many thermal features means that medical evacuation can take hours, making even moderate burns potentially life-threatening. The psychological draw of these thermal features is understandable. The brilliant colours, the mysterious steaming pools, and the otherworldly landscapes create an irresistible sense of wonder. Many visitors describe feeling compelled to get closer, to touch these natural phenomena that seem too remarkable to be real. This attraction has remained constant throughout Yellowstone's history, from the earliest Native American peoples, who considered many thermal areas sacred, to modern tourists who travel thousands of miles to witness these geological wonders. But the thermophiles that create the colours and the geological processes that heat the water operate on timescales that make human life seem insignificant. These microbial communities have been evolving and adapting for millions of years, creating ecosystems that are both ancient and constantly changing. The hot springs that appear so inviting and mysterious to human visitors are actually complex biological and chemical systems that have no tolerance for human intrusion. Dominica's Morne Trois Pitons. The first thing you notice isn't the heat, it's the sound. From half a mile away, long before you can see the grey-blue water churning in its rocky crater, you hear it. A constant, violent bubbling that echoes through the rainforest like some massive pot boiling on nature's stove. Then comes the steam, thick white clouds rising 60 feet into the air, visible above the canopy of tropical trees. By the time you reach the crater rim, the reality hits you with overwhelming force. You're standing at the edge of the second largest boiling lake on Earth, watching nearly 200-degree water rage and foam in a display of raw geothermal power that has been going on for at least 150 years. This is Dominica's boiling lake, hidden deep in the island's mountainous interior, accessible only by a grueling 6-hour hike through dense rainforest and across treacherous terrain. The lake sits in Morne Trois Pitons National Park, a UNESCO World Heritage Site that contains some of the most extreme volcanic features in the Caribbean. But even among Dominica's collection of hot springs, fumaroles and geothermal wonders, the boiling lake stands apart as something truly extraordinary. The lake measures roughly 200 feet across and 50 feet deep, filled with grey-blue water that maintains temperatures between 180 and 197 degrees Fahrenheit along its edges. The centre temperature has never been measured because no instrument can survive the violent boiling action that gives the lake its name. The entire surface churns continuously, sending massive bubbles of superheated steam exploding through the water, creating a spectacle that seems more like a scene from another planet than something you'd find on a Caribbean island. The discovery of the boiling lake by Europeans came relatively late in Caribbean exploration, largely because of its remote location deep in Dominica's interior mountains. The first documented European to reach the lake was Edmund Waller, a British government official who made the journey in 1875. His initial report described the lake as a cauldron of boiling water of unknown depth, surrounded by precipitous rocks. But Waller's account was met with scepticism in London. A lake of boiling water in the tropics seemed impossible to Victorian scientists, who assumed such features could only exist in volcanic regions like Iceland or New Zealand. The scepticism ended when H.A. Alfred Nichols, a British naturalist and physician, organised a proper scientific expedition to the lake in 1875. Nichols brought thermometers and measuring equipment, determined to document this impossible phenomenon. His measurements confirmed water temperatures exceeding 190 degrees Fahrenheit, hot enough to cook food or cause instant severe burns. More importantly, his detailed observations revealed that the lake wasn't just hot, it was actively boiling, with continuous violent bubbling action powered by something deep underground. Nichol's expedition also made the first attempts to map the surrounding area, which they dubbed the Valley of Desolation. The name proved accurate. The entire region around the lake was a moonscape of bare rock, steaming vents, and sulfur-encrusted soil where nothing could grow. Hot springs and fumaroles dotted the landscape, creating an alien environment unlike anywhere else in the lush, green Caribbean. But the boiling lake revealed its most mysterious characteristic in the decades following its discovery. The lake had a habit of disappearing. In 1876, just 1 year after Nichol's expedition, visitors found the crater completely dry, containing only steaming rocks and sulfur deposits. The water had vanished overnight, leaving behind a barren crater that hissed with escaping gases. Then, months later, the water returned, as hot and violently boiling as before. This cycle of draining and refilling became the lake's defining mystery. Historical records document at least 8 major instances of the lake emptying between 1876 and the present day. Sometimes the water would disappear for weeks, sometimes for months. In 1888, the lake drained so completely that adventurous visitors could climb down into the crater and walk across the dry lake bed, though the intense heat and toxic gases made such ventures extremely dangerous. The most dramatic disappearance occurred in 1901. The lake had been dry for several months when 2 local guides decided to descend into the crater to collect sulfur deposits. As they worked near the former water's edge, a sudden steam explosion erupted from the crater floor. The blast released a cloud of carbon dioxide and other volcanic gases that instantly displaced the oxygen in the crater. Both men were found dead hours later, victims of asphyxiation in what became known as the first recorded fatalities at the boiling lake. Early theories about the lake's behaviour ranged from underground water sources drying up to volcanic activity changing the heat flow beneath the crater. But as geologists began studying similar features around the world, a more complex picture emerged. The boiling lake wasn't just a hot spring, it was what scientists call a flooded fumarole, a volcanic vent where superheated gases and steam rise from deep underground magma chambers. Modern research has revealed that the lake's water is heated by a continuous flow of volcanic gases rising from depths of several miles underground. These gases, primarily steam but also including hydrogen sulfide, carbon dioxide and sulfur compounds, bubble up through fractures in the rock beneath the lake. The constant flow of gas not only heats the water, but also helps maintain the lake's level by creating pressure that pushes water up from underground sources. When the lake disappears, it's usually because these underground gas vents become blocked or redirected. Without the continuous flow of gases pushing water up from below, the lake level drops rapidly. The water doesn't drain away through cracks in the crater floor, it simply stops being replenished from underground sources. When the gas flow resumes, either because blockages clear or new vents open, the water returns. The temperature measurements that modern scientists have taken around the lake reveal the incredible amount of energy involved in this process. The water at the lake's edges maintains temperatures of 82 to 92 degrees Celsius, while the centre, where the most violent boiling occurs, likely exceeds 100 degrees Celsius, despite being at sea level atmospheric pressure. This is possible because the dissolved minerals and gases in the water raise its boiling point, allowing it to remain liquid at temperatures that would normally produce steam. Chemical analysis of the lake water shows extremely high concentrations of sulfur compounds, chlorides, and other volcanic minerals. The pH is highly acidic, around 1.5 to 2, making the water more corrosive than battery acid. This acidity, combined with the extreme heat, creates an environment that is instantly lethal to any form of life. Unlike many hot springs that support extremophile bacteria, the boiling lake is too hot, too acidic, and too violently turbulent to sustain even the most heat-resistant microorganisms. The lake's connection to Dominica's broader volcanic system became clearer as scientists installed seismic monitoring equipment around the island. The boiling lake sits within the Morne Trois Pitons volcanic complex, part of the Lesser Antilles volcanic arc formed by the subduction of the Atlantic-Oceanic plate beneath the Caribbean plate. The same tectonic processes that created the island's 9 volcanoes also power the boiling lake's extraordinary thermal activity. Recent monitoring has revealed that the lake's behaviour often correlates with seismic activity elsewhere on the island. Small earthquakes can sometimes trigger changes in the underground gas flow, affecting water levels at the lake. More dramatically, major changes in volcanic activity at other locations on Dominica sometimes precede or follow changes at the boiling lake, suggesting that the entire volcanic system is interconnected through deep underground magma chambers and fracture networks. The most recent major change at the lake occurred between 2004 and 2005, when water levels fluctuated dramatically over several months. Visitors during this period reported seeing the lake alternately drain to less than half its normal depth, then refill to overflowing, sometimes changing significantly from one day to the next. Temperature measurements during these fluctuations showed corresponding changes, with lower water levels often accompanied by higher temperatures as volcanic gases became more concentrated. Modern safety protocols around the boiling lake have been developed based on the tragic 1901 incident and ongoing research into the lake's hazards. The University of the West Indies Seismic Research Centre now monitors the lake as part of their volcanic surveillance program, tracking water levels, temperatures and gas emissions. When the lake shows signs of instability, warnings are issued to limit tourist access to the area. The dangers extend beyond the lake itself. The entire Valley of Desolation contains numerous other thermal features that can be equally hazardous. Hot springs with temperatures exceeding 180 degrees Fahrenheit emerge from the ground with no warning. Fumaroles release superheated steam and toxic gases at temperatures up to 200 degrees Fahrenheit. The ground itself can be unstable, with thin crusts covering scalding mud pools or steam vents. Despite these hazards, the boiling lake continues to attract thousands of visitors each year. The 6-hour round-trip hike to reach the lake has become one of the Caribbean's most challenging and rewarding adventure activities. The trail passes through multiple ecosystems, from lowland rainforest through cloud forest to the otherworldly landscape of the Valley of Desolation, culminating in the dramatic view of the boiling water from the crater rim. Guides who regularly lead expeditions to the lake report that no two visits are exactly the same. The intensity of the boiling action varies with weather conditions, atmospheric pressure, and the underground volcanic processes. Sometimes the lake churns violently with steam clouds rising hundreds of feet into the air. Other times the surface is relatively calm, with only gentle bubbling and modest steam production. These variations reflect the complex interplay between the volcanic gases rising from below and the atmospheric conditions above. The lake's future remains as unpredictable as its past. Climate change could potentially affect the water sources that feed into the underground system, while ongoing volcanic activity throughout the Caribbean could alter the deep geological processes that power the lake. Some scientists worry that increased seismic activity in the region could trigger more frequent draining episodes or even permanent changes to the lake's thermal characteristics. Current monitoring efforts focus on detecting early warning signs of major changes in the lake's behavior. Seismometers around the crater measure ground vibrations that might indicate changes in underground gas flow. Temperature sensors track both water temperature and ground temperature in the surrounding thermal field. Gas monitoring equipment analyzes the composition of emissions from the lake and nearby fumaroles, looking for chemical signatures that might predict changes in volcanic activity. The boiling lake represents one of the most accessible examples of active volcanism in the Western Hemisphere, offering scientists a natural laboratory for studying the complex interactions between underground magma systems and surface hydrothermal features. Each visit provides new data about how these extreme environments function and how they might change in response to broader geological processes. For the thousands of hikers who make the challenging journey to witness this natural wonder, the boiling lake offers something increasingly rare in our modern world, an encounter with geological forces so powerful and alien that they challenge our understanding of what's possible on Earth's surface. Standing at the rim of that grey-blue cauldron, watching 200-degree water rage and foam just yards away, visitors experience a direct connection to the planet's molten interior, a reminder that beneath our feet lie forces capable of reshaping entire landscapes. We've travelled from the burning underground coal fires of Centralia to the boiling waters of Dominica's volcanic crater, from the radioactive forests of Chernobyl to the acid lakes of Tanzania. They reveal the thin line between the habitable world we know and the hostile environments that exist just beneath the surface or beyond the next horizon. In every case, we found the same truth. Earth is far stranger and more dangerous than we imagine,